Okay, welcome back to S76. So tonight we actually dive into iOS programming, building on the material that you dove into with Rob last week. And what was that language that we spent the latter half of last week on? Objective-C, exactly. So let's see if we can't take a whirlwind tour of some of those topics and see if this will lend itself to recognizing some of the same constructs you saw last week, albeit in a different context, namely GUI programming today. So here was a canonical program, main.m. .m. That was probably a new file extension for some folks. What's the .m referring to? So methods, typically. So methods are where you actually implement your functions or your methods, and this is in contrast with the .h files. And a .h file in Objective-C contained what kind of things by contrast? So the interface, or the sort of the information that describes what the code is that you're about to implement. And this is an example that we'll see pretty much in every iOS application that we make, certainly ones that we make by starting from some of Apple's templates. And it is, I cannot think of a single instance for the next 4 weeks where you should ever actually touch this file. So you can take comfort in the fact that the way you get it is the way it should remain, but it actually is the file that kickstarts a lot of the magic that then proceeds to happen. And we'll start giving you a tour of that today. So let's work through this line by line as representative of some of the syntax we'll continue to see, even though it won't be in this particular file. So hash import, what does that do for us? First line in a file like this. Yeah. Yeah, it imports the library, specifically the library that's called the foundation library, which for Objective-C is all the basic stuff that you get with Objective-C, things like arrays and other types of objects, sort of like Java's collection classes and the like, so, or things you might get in C++'s standard library. So a lot of functionality right out of the box. And hashtag import means that those method declarations will be automatically loaded into this file, so you can just start using them, even though someone else implemented those functions and those classes. So int main just means that this function returns an int. For our purposes, that'll pretty much be inconsequential, but this is one of the means by which programs can signal whether they were successful or not. If a program like main returns 0, that means all is well. If it returns anything other than 0, what does that typically signify? All is not well, and there can be almost an infinite number of things that could go wrong, and that's why we use 0 for good and a non-zero value for anything else. argc and argv typically refer to command line arguments, things you would actually provide to a program by typing commands at a keyboard. That's not going to be applicable for our iOS programming. And then inside here, we see some syntax that's new to Objective-C. Most everything else we've seen thus far exists in C or in a form similar to C. At auto release pool refers to memory management. And we'll come back to this over time, but in a recent version of iOS, a whole bunch of useful functionality was introduced that essentially means that we can start thinking about memory a lot less. And I'll point out here and there exactly where there is interesting memory management going on, but know that 2 years ago, had you taken this class, your lives would have been much more challenging when it comes to implementing some of the stuff we'll dive into today. But Apple has lowered the bar to getting into Objective-C programming, in part by hiding some of the complexity of memory management. nslog is just a function like printf that will print a formatted string, but to a specific place, a standard logging mechanism that we'll actually see in Xcode, which recall is the IDE we'll use to program in Objective-C. Return 0 means that we're assuming all is going to go well, and we will pretty much never see this function again. Yes, questions? Good question. Should you start every program with auto release pool? Short answer, yes, but Xcode will actually write this code for you. So we'll actually see in a little bit a function quite like this, but with one additional line that kicks off the magic that is the SDK that comes with Xcode for iOS programming. So you can literally just take what's given to you out of the box. All right, so here's some syntax. And just to be clear, I've gone into Rob's slides and I've deleted some of the comments so that we can put them back to make sure that we're all on the same page before we forge ahead. So this is what you might see in a .h file or a header file. You said a moment ago that this is where declarations of methods and classes might go, but not the actual implementations. I have 2 comment symbols here. What goes where that first comment symbol is specifically? What do you put inside of an @interface declaration? So instance variables. And what's the definition of an instance variable, to recap?
Something that's
Okay, almost a circular definition here. What's an instance? Instance of what?
An instance of a class.
An instance of a class, otherwise known as an object. So an instance is just an object, an instantiation of a particular class. An instance variable is a piece of data, maybe it's 8 bits, maybe it's 32 bits, maybe it's even bigger, that's specifically associated with the specific object that was created using some class as its blueprint, so to speak. So this is where our instance variables might go. And how about outside of the curly braces, but before the @end symbol? What goes where those second comment marks are? Class methods, sure. So we can declare class methods there, not implement them, but declare them, which means, hey, compiler, here is the name and the signature, all of the arguments for a method I'm going to implement elsewhere, elsewhere being the .m file. And what else besides class methods can go where that second comment symbol is? Instance methods. So instance methods are sort of the opposite of class methods in the sense that a class method can be called even before you instantiate an object. So if you just know a class's name, you've never actually used it as the blueprint for creating an object, you can call a class method on that class without an object existing. And this is hugely useful because you saw one, at least last week, that allows us to avoid what would otherwise be a chicken and the egg problem. If we didn't have class methods, we could never allocate or alloc an object of a particular class, and that was the plus alloc that you might recall from last week, and we'll continue to see tonight. An instance method, by contrast, is one that you call on an object or a particular instance of a class. Exactly. So we'll start seeing a lot of this, and we'll start writing our own classes in this way. But there's one last syntactic detail that's worth recapping here. The colon space ns object means what with respect to foo? It inherits from the NS object class. And most classes that we would ever write, most classes that you'll use in the SDK that Apple provides, do at some point descend from NS object, even though there's typically even more layers than just one between you and that root class. So we'll see more of that in the time to come. So instance variables and declarations of methods. And these slides are online if you'd like to download them as usual. .m files contain implementations. And this is one of the sort of unfortunate design decisions of Objective-C that you may recall last week. Even though you do have balanced curly braces in a lot of places, you also have wonderfully asymmetric ways of starting and ending a sentence, so to speak. You have at implementation and then at end, which is the opposite. But we saw this a moment ago. What goes where that comment symbol is? The definitions or the implementations of those methods. So you typically begin by copying and pasting the declaration or the signature of your methods from the .h file, but then you proceed to open a curly brace, implement it, and then close a curly brace. And we'll certainly do that tonight as well. So there go our definitions of methods. All right, so now a bit more syntax. Messages we looked at last week. And this is a valid line of code that assumes that a class called student already exists and has been declared and defined elsewhere. It could someone, in somewhat technical but roughly layman's terms, explain what the two halves of this line of code are doing. Let's start with the side on the left of the equal sign. What's going on with those symbols, student, star, student? Yeah? Creating an object with a pointer called student, close, but we're not doing as much as you just proposed that we're doing. We're doing a little less. Yeah?
So create an object named the student that belongs to the class of the big student.
Again, I'm going to find fault with your use of create an object. Yeah?
Create a pointer to where the object will live.
Exactly. Perfect. So create a pointer, which is just storage for an address, and the name of that pointer is apparently going to be student in lowercase, and that pointer is going to point to, in other words, store the address of an object of type student, capital S. So all that is happening on the left-hand side of that screen is that we're allocating probably 64 bits or 8 bytes to store the address of what will be a student object. But at this point in the story, only looking at the left-hand side of that line of code, none of the object instantiation has happened yet. All we've done is created an empty placeholder for what will be the address of some student object. So now we can rewind and go with the right-hand side, what's happening on the right-hand side of the line of code? Exactly. On the right-hand side of the code, we are allocating, in other words, instantiating an object of type student. And what that syntax with the square brackets is presumably doing is somehow returning what to the left-hand side for assignment? The address. So alloc is apparently not only allocating the object, it is allocating it and then handing back the address, something like 123, wherever it is in RAM. And so that value is what's getting stored on the left-hand side, which is that 64-bit chunk of memory designed to hold the address of an object. Hand over here, Peter.
So without calling init, is it actually an instantiated object, or is it just the memory has been allocated?
Good question. Just the latter. So when you call alloc, all you have done is allocated the object and therefore returning its address. You have not initialized it, but in many cases, initializing it doesn't have an actual effect. It's rather a human convention, a programmer's convention that we've adopted in the world of Objective-C, that even if your init method doesn't do anything, it should exist by convention. You should call it. So this line of code, out of context, is not complete. We have not initialized the object just yet. Now, because student, and in the previous slide foo, descend from presumably NS objects, the folks at Apple essentially gave us for free an implementation of init for any descendant class. So we could call init here, we could call init on a foo object, and rest assured that it will actually work. It just so happens that the person who implemented the init method for NS object just essentially returned immediately. They didn't actually do anything because you won't know what the descendant class is how it's supposed to be configured anyway. So in short, whenever allocating an object, you should always allocate it with alloc or some similar mechanism, as we'll see, convenience methods as they're called, and initialize it. But you sometimes have different ways of initializing objects. There are methods beyond just the one called init. There's longer names that we'll sometimes see, and we can create them ourselves. Yes?
Auto-release tool will release that memory at some point?
Good question. It's not so much that the auto-release pool will release that memory at some point, but we have created in main a pool of memory designed to be auto-released by the operating system later. So short answer, yes, but not quite with that language. This object will eventually be freed when the operating system realizes no one needs this object anymore. And that's the difference vis-a-vis 2 years ago. We, the programmers, would have had to keep track of when we're done using this student object and explicitly free it or deallocate it later. But we no longer have to do that. All right, just a couple other things to recap. So there's that student init method. And I keep calling these methods, but really in Objective-C, the lexicon is a little different. When you have open bracket student init close bracket, you're not exactly calling the init method. You're passing the init message to the student object. Now, at the end of the day, it's functionally the same thing. It's just sort of a different view of the world. But when you see messages being described, a message is the act of calling a method if you come from the world of Java or C++ or other languages that have more conventional methods. How about these bottom two? Student age and student set age. What do you think the first one, student age, does? It's a valid expression. Yeah? It's a getter. So that presumably returns the value of an instance variable called age. All right, how about the one below it? So a setter. So in this case, it's presumably setting some instance variable to the value 20. All right, and it turns out, as you may recall, the instance variables underneath the hood might not even be called that exactly. That's an implementation detail for which there are conventions. But we'll see over time how we can choose those instance variables on our own. All right, a couple more complex topics, not that you have to be totally comfortable with just yet, but just be mindful of as we see them later tonight. So a category allows us to do what, if you recall? Yeah? It's like an extension to a class. What do you mean by that? Yeah, exactly. A category allows you to add more methods to an existing class. This is particularly helpful for large classes that might have, let's say, 100 different methods or 100 different selectors that you can pass to objects, and you just want to kind of categorize them. You want to have the messages related to this functionality, different messages related to this functionality. You can put them in distinct categories. You can put them in distinct files. Different people can work on different subsets of functionality for a class, so they're useful in that regard. Somewhat similar in spirit to JavaScript and the prototype property, whereby you can add functionality to existing objects via a somewhat similar mechanism. All right, and we will also see them in the context, sort of a clever trick that folks have adopted. We'll also see them as a means of implementing effectively private members, private methods, or instance variables to a class that you don't want the rest of the world to know about by putting them in your .h file. But we'll see that by example. Yeah?
What's the design guideline? Do you put functionality in categories, or do you put them into their own classes?
Good question. So what guideline do we decide where to put our method declarations? For instance, why might we put Baz inside of a category as opposed to somewhere else? So a couple of reasons, just to recap. One might be if I am the guy implementing the bar category of methods, I just have chosen for development convenience to put them all in one file, therefore all in one category, so that I can kind of mesh nicely with colleagues who are implementing other categories of methods. So it's just programmatic convenience. But we'll also see instances where if you want to have instance methods associated with a class, but you want them effectively to be private, not broadcasted or advertised to the world, you don't want to put them, therefore, in your .h file, because then anyone poking around at your library would see them by nature of what a header file is meant to be. It's meant to be included by other people or imported by other people. So you can tuck them away and still document them and still teach the compiler that they exist, which is helpful for you using Xcode since it knows more about your code. But you're not advertising them to the rest of the world. It doesn't make them truly private, because you can still send any message to any object that you want, and just on a whim, hoping that it exists, and if it exists, it will be responded to. But it's a mechanism to approximate that idea of privacy. It's just not strictly enforced. So I would keep those two guidelines in mind. And lastly, protocols. This is a more complex manifestation of this than we'll see later today, but a protocol lets us do what in Objective-C? Yeah?
Find a set of methods that should be implemented by the class that implements the protocol.
Exactly. It allows us to define a set of methods that should be implemented by some class that adheres to that protocol. So if you're familiar with Java, it's effectively an interface, and other languages have the same conventions. It is a set of methods that you, a class, promise to implement if you declare yourself as adhering to that protocol. And there are ways of specifying that the methods are optional, but by default, they would typically be required. And the compiler will yell at you if you say, I'm implementing the NS copying protocol, but you, the programmer, forget to actually get around to implementing the required methods to make that possible. All right, so the biggest takeaways from this recap, I would say, are 1, what a pointer is, 2, what an object is, and I think those two would make me pretty happy moving forward. So just to recap, an object is an instantiation or an instance of a class. A pointer is? It's an address of some piece of data, and that will often be the address of some object. So if you're comfortable with those two definitions, I think we can get through this. All right, so iOS. So iOS adheres to a design paradigm, generally known as MVC, which stands for, as you might guess, Model View Controller. So we're not really going to spend any time on the M today, but we will spend time on the C and the V, the controller and the view. And you can think of the controller of a program that adheres to this MVC paradigm as really being the brains of your program. It's where you probably spend much of your time implementing your program's logic, responding to user interactions, displaying things on the screen. But with that last goal, displaying things on the screen, all you do is tell someone else to actually do the rendering of information on the screen. So if I'm a program, for instance, whose purpose in life is to display someone's account balance in their bank account, I, being the controller, would respond to the user's username and password. I might somehow check that their username and password are correct when they log into the bank's website. And then I, the controller, upon realizing, OK, this is user David, I'm going to go check his bank account. And I'm going to check that by asking someone called the model, but more on that in the future. Once I have that value, like $100, I'm then going to hand that value, 100.00, to something called a view to actually present that information to the user. So in other words, data is typically stored in the model. In this case, that's where my financial numbers might be stored. The controller is going to be the brains. All of the code that you write to sort of respond to ifs and elses and for loops and while loops will often be inside of your controller. And then when it comes time to display the results of all that number crunching to the user, you typically hand the data that you have gathered or computed off to something called the view. And the view takes it that last mile. It's sort of the HTML and the CSS of the world of the web. In the context of iOS, it's going to have to do with what the user sees on the glass screen. So this is a paradigm that you should keep in mind, because at many junctures, particularly with the iOS project, the staff's choice, you'll have to decide for yourself, where do I put this variable? Where do I store this data? Where do I actually display something on the screen? And the goal with adhering to a design paradigm like MVC is to not blur these lines and to adhere to these best practices so that when you start collaborating with someone else, or when some new device comes out, like the newest iPad, which is maybe bigger than the 2 existing iPads, you don't have to change how you're representing your data. You don't have to change any of your so-called business logic, the guts of your program. All you have to do is change or add a new view. And this makes it super easy to deal with things like iPhones and Windows phones and Android devices and all of the different displays or views that a user might interact with. You don't have to touch the essence of your program. And that just makes life much, much easier as your programs get more complex and more interesting. All right, so here is now, how an iPhone application or an iPad application works in more detail than we need for today. But let me go ahead and zoom in on a portion of this. The key feature of this picture is the fact that there's that circle in the bottom left-hand corner, generally known as an event loop. And as you might imagine, if you have an iPhone or an Android device or anything that's a touch screen these days, for the most part, it's just sitting there for the entirety of its life, waiting for you to do something or waiting for something external to happen, like an SMS message coming in or a phone call coming in. So it makes sense that the essence of a smartphone or a tablet these days is just to sit in an infinite loop, waiting for something to happen. And that's indeed what's really happening in some form underneath the hood. So this is a picture from Apple's documentation, the URL for which is at the bottom of the slide if you'd like to read the whole article. And when you launch an application, you tap an icon. The main function gets invoked, which just like in the world of C and Objective-C, independent of iOS, is the first function that gets called. We'll see that there's typically a function called UI application main that's called by default, by convention, just because Apple designed the infrastructure to run that way. And then we load the main UI file, UI being just user interface, so something having to do with the visual aspects of my program. First initialization, whatever that means. Maybe it's loading some of my top scores if it's a game, or maybe it's loading my bank account information from cache, something like that, some piece of data. And now we have a fork in the road, but let's see, let's just go straight down and assume that I haven't written any code yet. We're going to restore the UI state. So if I, for instance, played this game 5 minutes ago, but then had to take a call, maybe I need to redisplay to the user where they paused the game rather than starting from scratch. So that's what we mean by restore UI state. Initialization, whatever that means for my particular program. And then once we reach this blue rectangle, we've activated the app and just start listening for the user to touch the screen, for a monster to come by on the screen, for a phone call to come in, for an SMS to arrive. We just keep waiting for something interesting to happen. Meanwhile, stuff can happen. And this line going from left to right to left to right is pointing at this box that says handle events, where an event is any of the things I just described. Something external triggered by the user or external triggered by the network to which you're connected. Now, meanwhile, we have some slightly more technical detail on the right. This is the last portion of this picture. On the right, everything in this big white box is my code that I've written. So we see in a monospaced font some functions or methods that we'll soon see in some actual code. And for instance, one of the functions up there is called application will finish launching with options. This is a common characteristic of Objective-C methods. They are atrociously long named, but they're very descriptive. And they capture, their names describe what their arguments or parameters are. Various methods, which is a nice hand wave there. Application did finish launching with options. So notice the difference. First one is will finish, so it's about to finish launching. Did finish means it's after the fact. So if your code needs to do something before or after that change in state, you have that control. And then lastly down here, application did become active. So if you have ever implemented a game, this kind of implies that you can, for instance, immediately resume the game because somehow or other Apple is providing you with these hooks into interesting key events. This is quite like we saw in JavaScript with the world of DOM. On click, on submit, all of the interesting things that can happen in JavaScript can happen in similar spirit in the world of iOS. So this white box is what we're going to start writing today, and Apple has written all of this stuff for us and essentially just allows us to hook into this event loop, waiting and listening for interesting things to happen, just like JavaScript and jQuery allow us to do quite readily in the world of HTML. Yeah?
Event loop, say a tap on the button, will the event affect for the run in its own thread? Or will it effectively block the event loop?
Good question. Short answer is it depends on what kind of action is and where it happens. For instance, if you have a program that's running and you get a phone call, Apple's threads can take higher priority and therefore interrupt your program and actually show you on the screen who is actually calling. So multi-threaded, yes, but not necessarily in the sense that you can't continue running while that phone call is in progress. So there are certain design paradigms that Apple adheres to that forces your threads to go to sleep when more important things happen. And this is in contrast to the world of, say, Android, which lets you do a lot more. And the argument long-standing for Apple has been that this way they can police battery life better so that you don't have some thread in the background just churning and churning away. But the price we pay is that if you run, for instance, the Gmail app on your phone, you can get notifications and be informed that you have new mail with the little badge number being incremented. But if you want to actually check your mail, you have to load Gmail, refresh the screen, wait a few seconds, and then see your email. And I bring this up as an example because it drives me nuts. Whereas the built-in mail application has is more tightly coupled with the operating system and can actually do all of that in the background in its own thread. All right. So UIKit is where we begin our look today. And UIKit is just the user interface related SDK that Apple provides to the world, software development kit. So these are some class names that will quickly become familiar to us, some more so than others. And they describe different classes that allow us to do different things. UI application is the class that describes an iOS application. UI application delegate is similar in spirit, and we'll come back to delegation and protocols later today. UI view describes the aesthetics of a program. It's a class that represents something that's on the screen. Maybe it's a rectangle, maybe it's a button, maybe it's a text field, so something like that. UI view controller is unfortunately named. Apple calls controllers view controllers. So they are distinct. View controller is the C, UI view is the V. View controller is, again, just a C, not a V. It's the brains of our application typically. And UI window is just a class that represents the rectangular piece of glass in some form that your application is going to run inside. So let's go ahead and write our first application. It turns out we have different starting points that Xcode provides us with. We don't really have to use any template code that Apple provides, but you'll typically find that it's a great way to get started quickly, even if you just start with an empty application. So let's do this. Let's see if we start by loading Xcode here and going up to the File menu and going to New Project. So not New File, but New Project. So I get a whole bunch of folders and a whole bunch of files for free. Notice that we've got some organization here. And last week, you may recall poking around with OS X because we just needed some simple Objective-C programs, not necessarily iOS. Tonight and hereafter, we focus only on the top half of that menu under iOS, where we have an application category, framework and library, and other. Most everything we'll be interested in for now will be under iOS application. So here are those same template names we saw a moment ago. And if you're familiar with an iOS device, you probably recognize some of the design paradigms here. The master detail view looks like it has a little menu on the left-hand side and then more information on the right-hand side, like the built-in mail application. OpenGL game refers to a graphics-based game. Page-based application means something that has that sexy page curl that happens from the bottom up. Single view application is a place we'll spend some time today, since it just allows us to have some basic sample code and to get started quickly with a user interface of our own. Utility application, which is something like the weather or the stock application, super simple, but typically have a button that allows you to flip it around to see some settings. And indeed, that's the template you'll use for the next project starting Wednesday onward. And then the last one down there is tabbed application. Which is also a common paradigm, at least in iOS 6 and prior, where you have got some big icons at the bottom that toggle state among different portions of a program's functionality. So let's do something super simple like empty application. And according to the instructions, this template provides a starting point for any application. It provides just an application delegate and a window. So let's see what this actually gets us. And what we'll do is today is spend some time in particular on what the sample code is that Apple provides, not because it's interesting, but because it's representative of how you might write your own applications. So here we have knowing a number of prompts. I'm going to go ahead and just call this test. My organization name can be whatever I want here. I'll say Harvard University. Company identifier, you just need a probabilistically unique string, really, so that if you push an app to the App Store, it's distinct. We'll go with edu.harvard, which is a common paradigm in the Java world for package names. If we own harvard.edu, presumably no one else in the world is going to use that same prefix for their applications, but it's just a human convention. Class prefix, I'm going to leave blank because it doesn't matter. Devices. For lecture, I'm going to typically choose iPhone, really just so that it fits nicely in the screen so we can see everything. And then there's a few options here. Core data we'll come back to in the future, but it has to do with a abstraction layer for storing data in the equivalent of a database. Use automatic reference counting is that memory management feature I alluded to earlier, having come out a couple of years ago, that makes our lives easier, so we'll leave that on. And then include unit tests. I'll uncheck those for now, but we'll come back to that in time as to how to write tests for your own code. I'm going to go ahead and click Next now. It's asking me where to save it. I'm just going to save it wherever on my desktop for now. For source control, just to keep my directory simple, I'm going to uncheck that for now, but by all means use the built-in Git functionality for doing version control, and we'll defer to any number of online tutorials for how to use that in Xcode itself. Yeah?
Do you have to adapt your code a lot if you choose iPhone and iPad, or is it
Good question. Do you have to adapt your code a lot if you're developing for iPhones and iPads? It really depends on your application and to what extent you want the user interface to just grow to fit or to rearrange itself somewhat. For instance, if you don't implement a different view for the iPad specifically, what Apple does by default is it shows you your iPhone view, but in a tiny subset of the window. And they do give you a 2x button to zoom in, but most every application I've ever seen that just relies on that looks awful. So you would typically want, as a developer, to somehow customize your interface, even if it's just by providing higher resolution graphics for the bigger device, so that it doesn't look like someone just zoomed in on your application. But short answer, it depends. And because of MVC, it's actually relatively easy by not changing the essence of your program, just designing a new view that has similarly named variables, so to speak, to hook into your data. All right, so now I'm going to click Create, and let's start poking around Xcode. And let me go ahead and hide some distractions for just a moment. And here we have, let me move this so that everything's in view on the screen here. Here's everything we have to begin with. I'm going to wave my hand at all of this stuff in the middle because generally you can dive right in without having to change any of those configuration details. And this is the stuff that's nice to get for free out of the box rather than opening up something like TextEdit and just starting to write Objective-C code or Vim or Emacs or whatever your preferred text editor is. Xcode just sets up a whole bunch of defaults for you. So let's instead focus our attention on the files that you get for free with an application. But before we do that, let me zoom in on the top left-hand side of the screen. Notice that Xcode is so user-friendly. It's just like iTunes. To run my program, all I do is click play. And if I go and do that, build succeeded. What's happening in the background is my iPhone application is launched in the software-based simulator. And voila, I am now an iPhone programmer. So really, that's all it takes to make an iPhone app. And I'm sure back in the day, I mean, there have been stories, as an aside, where someone made like a Ruby app, was it? Which was just a stupid JPEG of a Ruby, the gem, submitted it to the App Store, put a price of like, you maybe recall this, $1,000, and like 4 people actually bought it. And it was really just an image of a glistening gem. So it was that easy for that person to make that application. So this could be you next. So what's actually going on underneath the hood? Well, let's just notice we've got a white background. We still have the status bar at the top. So there's still some built-in functionality there. And if I minimize it by going like that, there indeed is my test application on the desktop of my iPhone. So let's look at what files made that possible, uninteresting though this application is. So I'm going to expand these folders. As an aside, they're not necessarily folders in reality. They look like folders, but they're technically groups, which means if you poke around the hard drive of my laptop, you won't necessarily see those same yellow folders. All of the files might actually be in one big folder together. So this is just an illusion for organizing your code like you might in Eclipse or something similar. All right, so it's kind of overwhelming how much stuff there is. So let's start ignoring some of these things quickly. So at the bottom, under products, is test.app. This is just I'm the only one that can see that. So at the bottom of the screen here is test.app. That refers to the program that via that play button I already installed onto my phone. So that's the compiled application. So it's not interesting beyond the fact that it exists. Now let's close that to avoid the distraction. Under frameworks, I see UIKit, Foundation, Core Graphics. Which of those have we seen or mentioned before? So Foundation. So we saw that last week. We saw that earlier in some of our Objective-C code that simply had a reference in the import line to some library that someone else wrote with a whole bunch of functionality, a whole bunch of classes and methods that I don't have to worry about. I can just use them without implementing them myself. We also heard verbally UIKit. So it's inside this library that we're about to get all of the interesting functionality that gives me buttons and text fields and things I can touch and click on the glass of a screen. And Core Graphics we won't use today, but this refers to a 2-dimensional graphics library with which we can draw squares and rectangles and more interesting things on the screen. So let's collapse that and ignore. Now we have some pings. So default at 2x, default.ping, default 568h at 2x.ping. Does anyone know what these are? Yeah. Images for? Exactly. So there's some default images that if you read the documentation must be named exactly this, though you could override them if you really wanted. And these are just the images that the user sees as your application boots up. Now for an application like this, we barely even saw them because the thing loaded so fast. But if you have a network-based application, a game that logs into some game server, you might have a couple seconds of latency while the program loads. This is where you'd see the Angry Birds splash screen or something similar like that. So it's just a convention. They're not really interesting for our purposes. Apple gives them to us for free, so let's ignore them hereafter. Test prefix.pch. This is a pre-compiled header, which just means a file that will do some stuff for us that we'll never again, at least for the next several weeks, have to think about. In this case, it has to do with some backwards compatibility, but it's just some additional metadata that Apple uses to bootstrap a program without our having to write this. So I'm also going to ignore that. So we're really whittling this down to the essence. I'm going to skip main.m because that's clearly of interest. Testinfo.plist. This is like a preferences file. A plist is a property list. This is just an XML file underneath the hood. A whole bunch of tags and values and attributes and the like, similar to what you might have seen with Ajax in the world of DOM and HTML5. Xcode is simply reading that XML file and showing it to us in this very pretty fashion with rows and columns, but it's just an XML file underneath the hood. This is a GUI with which to edit it. I'm not going to change any of these things now, but you can kind of infer from the names of the XML elements here what kinds of things you can tweak, what interface orientations you support, up, down, up, left, right, left, those sorts of things can all be configured via point and click by editing this kind of file. But we'll stick with the defaults for now. If we go back to the directory structure over here, info.plist.strings. So we'll come back to this perhaps in the future, but this makes it easy for us to localize our application. What does that mean?
Translating to other languages?
Yeah, exactly. Translating it to other languages. So we want to expect you to support more than just English for the staff's choice of projects, but this is where you could define some key value pairs where the keys are like constants that you use in your actual code that represent the words you want your program to actually display. And based on whether the user's device is in Spanish mode or Chinese mode or English mode, a different plist file will be loaded containing those strings and used on the interface for your native speakers. So it's a nice way of factoring out all of the words for a program and putting it, sorry, not in a plist, but into a .strings file, which is essentially just a text file. So that leaves only 3 files of genuine interest. So let's dive into main.m. And it looks, hopefully, a little familiar. Some new stuff, but mostly boilerplate. So let's zoom in. At the top, we have a whole bunch of comments that are outputted automatically by Xcode, depending on how I've configured the program when I first installed it. First line of interest is import. This is apparently giving me access to what kind of functionality, that import line? Sorry? So UIKit, so user interface related stuff. This is allowing me to write a graphics-based application as opposed to the command line stuff you guys did last week with Rob. Import appdelegate.h. Don't know what that is yet, but I remember seeing it among the remaining files, so we'll come back to that in a moment. That's a file that I get to actually interact with. Here's the promised signature for main. We're not going to touch this. Here's auto release pool, and the only thing that's a little different now is that apparently main's sole purpose in life in an iOS application is to return whatever the return value is of a function called UI application main, passing in its argument count, so whatever was typed at the command line, which probably has no significance unless you override some of the default settings in Xcode, passing in argv, same thing, nil, whatever that is. It's essentially null, but with some magic around it. And then lastly, let me scroll to the right. It's a little long, this string, and it's wrapping. NS string from class, appdelegate class. So let me see if I can avoid the wrapping by shrinking the window a little bit. So here we go. We are returning whatever the return value is of UI application main, passing in these 3 things, which don't look very noteworthy. The interesting one seems to be this last one. That's effectively passing in a reference to a class named appdelegate. So this one line of code is what's used in the iOS world to hand off control, either briefly or for quite some time, from main to a different class, that class being appdelegate. And it's aptly named in that we are going to delegate control of my application to a guy named appdelegate. So that's the class that I, the programmer, apparently should start writing if it doesn't exist just yet. And as soon as appdelegate is done, apparently main wraps up, my program quits, and returns by default, it's not there explicitly, 0. So this is how we make this leap from main.m to whatever my higher level iOS application is. So we'll never again really need to look at this file. You can't think of any instances in the next few weeks where you'd even want to touch this file. So I'm going to close supporting files altogether and leave us with just 2 files now to glance at. UI application main, it's, sure, C function, yes. Happens to be capitalized, but it's a function, not a method. All right, so when looking at files for the first time, I would generally suggest to start with the .h file, in part because it's simpler, usually shorter, and also because it's often more descriptive. So let's start there, and indeed it is short. Let's see what's going on. A whole bunch of comments at top. I'm importing the UI kit again so that apparently my class can have access to its functionality. And now we see a similar construct to what you saw with Rob last week, and we recapped a bit ago, at interface, appdelegate, UI responder, open bracket, UI application delegate, close bracket. So let's start translating this into slightly less technical English. What does that one line of code do? Yeah. Okay, it says what's a child of UI responder? Okay, it says that the class called appdelegate is a child of UI responder. Good. And what else? And it adheres to the UI application delegate, and I'll scroll to the right to confirm, protocol. So what does that mean? It means not only does it behave much like a UI responder object does. I have no idea what that is, but it sounds like something Apple wrote because it starts with UI, part of UI kit. And UI application delegate is apparently a set of methods that Apple says I have to implement if I implement that protocol. Now this, for the most part, is copy-paste. We won't be so presumptuous as to change these defaults. We'll typically isolate the code that we write else to other files or subsets thereof or to new files of our own. But let's focus on one other detail. Inside of this class definition for the app delegate class, there's also a property. What was a property? Yeah. Yeah, exactly. It allowed us to synthesize, so to speak, a getter and a setter for ourselves automatically. In other words, to provide programmatic access, functional access to what's typically an individual instance variable. And what's useful about this is that you can specify some attributes for those setters and getters. And we'll see this in more detail before long. But non-atomic just means, hey, Xcode, when you generate that getter and setter for the property called window, don't bother writing thread-safe code. And by thread-safe, I mean a whole bunch of special synchronization-related code to make sure that only one person can call this function at any given time. The reality is, it's just not going to happen. By convention, this does not need to be atomic code. And by specifying that it should be non-atomic, it makes the getter and or setter faster. So we won't see in the coming weeks really an instance where you need atomic. And technically, it's there just because atomic is the default. And I want my getter and setter to perform ever so slightly faster, even though we humans would never notice. Good question. Are they open source? You can see the header files, the .h files, but to my knowledge, not the actual implementation files, at least not from recent versions of iOS. There may very well be older versions floating around. All we get is the compiled versions of those files and the header files, which are readable. All right. Yes?
Can you give us an example of when you would have to use the atomic?
If you are writing when would you use atomic as an attribute? If you are writing code that supports multiple threads, so two things happening at once, and each of those threads might want to access some value. So let me contrive an example offhand. So iOS now supports printing capabilities. So for instance, if you had some program that allows you to print your notes, for instance, in the Notes application, if the Notes application were multi-threaded, so it could do two things at once, and one of those things happened to be printing, and another thing happened to be editing, which surely the Notes application supports, if the printing application, the printing feature, needed to read the contents of your note, the contents of your note might be implemented by way of an instance variable and accessed by way of a getter and setter implemented as a property. Meanwhile, I, the human, with my fingers, might want to actually be editing that same note, and therefore the editing feature might also need to read and or write, get and or set that instance variable through this property. And it's probably not a good thing if I allow both the printing functionality and the editing functionality to look at the value and change that value at the same time, because I might say print now, make some changes, and all of a sudden my printer starts printing out part of the old version and part of the new version, unless I've somehow locked access to that file. So it's contrived in the sense that you can do things so fast that that's not going to happen. And you can make a copy, in theory, of the instance variable and void that problem altogether. But that's the spirit of it. If two things might simultaneously try to read and or write the same value, bad things can happen, like garbled printouts in that case. Yes? Read only. Read only is another. Read only gives you a getter but no setter. Good question. And strong, this one's more easily explained in the future after some number of examples, because it refers to memory management, in particular that automatic reference counting feature that I alluded to earlier. And we'll see this in the context of some GUIs that we actually start programming. So we will revisit. All right, so appdelegate.m is the last place for this program. And recall that this program only loaded a white screen. So all of this effort just to load a white screen, but we'll see in our next example that you can do much more with relatively little additional effort. So this file is a little overwhelming, but thanks to the green lines here, it turns out it's mostly comments. So it's just boilerplate code that Apple provides, and we can actually delete most of this just to simplify. So let me zoom out just to get the lay of the land. On the top of the file, we have some comments. I'm importing appdelegate.h. So appdelegate.m is importing appdelegate.h, common paradigm for the methods file to import the header file. At implementation appdelegate, what does this mean? Translate that one line of code. What's that line of code telling Xcode? Yeah. Exactly. Here comes the implementation of the class called appdelegate, which was declared in the file called appdelegate.h. So this method is hugely named. Application, actually, good opportunity for a review. What is the name of this method? Or more precisely, what is the name of the selector? Yes? Good. And as humans, we typically wouldn't say the colons, but it's exactly right. They're part of the name of the method. So application did finish launching with options. So Objective-C, recall, supports essentially some variant of named parameters, where they're not named in the sense that they appear inside of parentheses, as might be common as key value pairs or as JSON objects in the world of JavaScript programming. But the names of methods in Objective-C are meant in spirit to read like, frankly, full-out sentences. So they do exactly what they say. So what does this one do? I honestly have no idea at first glance. It seems to be code that someone else wrote. Indeed, Apple put it in this template for me. But then there's a few lines of implementation inside of it. Let's take a look here. Self.window gets UI window alloc, init with frame, UI screen main screen bounds. All right, this looks like probably the most complex line of Objective-C code we've seen thus far, but it's really just the combination of very simple building blocks. So someone on the left-hand side, what is self.window referring to? What is that? This window? It's referring to this program's window, and how about more technically underneath the hood? What is self.window, W-I-N-D-O-W, referring to? The view, close. The property. So window, recall, was the name of the property that we saw in what file? appdelegate.h. So we declared a property called window, and that property was of what type? It was of type UI window, capital UIW window. Okay, and it was a star, which means a pointer there too. So self.window, and again, for those following along at home here with laptops, feel free to download the source code from the course's website so you can toggle back and forth among these files if you would like. So self.window is effectively invoking a method. Which method? The setter. So this is one of these pieces of syntactic sugar that you get with Objective-C. We could implement this same line of code by literally calling setWindow as the setter method that we get automatically by declaring a property. But one of the purposes of properties in Objective-C is just to simplify our code so that we don't have these damn square brackets all over the place and very traditional method calls. It's just so much more readable, just like in JavaScript, to have this dot notation and then an assignment operator, the equal sign, right next to it, which effectively invokes that setter. But it's syntactic sugar in that underneath the hood, this is just a message being passed to an object to set some value. But it reads much more clearly this way. Self.window is going to be assigned what value? All right, so well, someone else, what does this chunk of highlighted code do for us? Okay, it allocates a UI window object. I don't really know what that is just yet, but it sounds like something that's useful to have, a window for my application, so I'm allocating it. I'm not calling init, though. I'm calling a slightly differently named method, init with frame. And this, again, is largely a human iOS convention or Objective-C convention. Init is typically the default method that you'd call to initialize an object. But if it makes sense programmatically to initialize an object with some arguments, the convention is to call it init, then capital letter of whatever it is you're adding to the object. So use camel case. And init with frame, I don't know what a frame really is, but it seems to be related to the screen and the screen's bounds. So let's look to the right-hand side there. The value of this argument, so to speak, is going to be the result of what? Calling UI screen main screen. So I'm not calling alloc here. Turns out this is a class method called main screen that apparently, if we read the documentation, is returning effectively a pointer to an object of type UI screen that represents the only screen on my device. So the screen is, you think of it as the glass. Meanwhile, that glass is a fixed size. So when I pass the message called bounds to this UI screen object, what do you think bounds returns? Yeah, the dimensions, the height and the width, effectively, which is going to be a little different if it's an iPhone 3 or an iPhone 4S or an iPhone 5, depends on the device, or an iPad, depends on the device potentially. And so this is a programmatic way of getting myself a UI window, which we'll see is like a container. It's just a special UI view. It's the parent of all other view-related objects on my application. I'm just initializing it dynamically, so I don't even have to know in advance what size of screen this is going to support necessarily. So a long-winded way of explaining just how you get access to a window, which again is going to be a big rectangle that we can start putting all of our buttons and text fields and keyboards and all of that on the screen. Now this is just a comment. Override point for customization after application launch. So this is just someone at Apple wrote this comment for the rest of the world to just kind of know where we could start plugging in code of our own. And we'll get to that. But now let's see what happens after. Why is this program's background white? Apparently because of line 3 here, self.window.background color gets UI color white color. So here too, we have some conventions. Self.window is the property that's referring to my window object, whatever that is. It's a rectangle, a canvas on which we'll paint other objects. .background color, this too is a property. And I know that because of the fact that there's a dot there, honestly. That's my clue that this is another property associated with that object. And meanwhile, UI color, I'm going to guess is a class, just because it's capital U, capital I, capital C. It's following the conventions that Apple has for class names. What kind of method is white color, apparently? So it appears to be a class method, because if UI color is a class, and we're not calling alloc, the only other way to talk to a class without having an object is through a class method. So white color is apparently a predefined message that I can send to the UI color class and get back some representation of white. And maybe it's effectively a number like FFFFFF. It's something like that that represents the color white, however Apple implements it. Now, I'm getting a little tired of taking myself for taking my own word for it. So let me try a little trick of Xcode here to start digging in. If I go and hover over UI color, let me zoom back in, while holding Option, notice that this is clearly a keyword of interest, and notice that my cursor has become a question mark. So this is one of the nice features, honestly, about Xcode. It's probably, of all the IDEs I've used, Eclipse and NetBeans and others, it's honestly probably the best. It's unfortunately pretty much designed only for Apple programming, but it's a really nice IDE in part because it's very instructive. So if I now click on UI color, notice that I'm going to get a little pop-up, and a lot of IDEs have this. So this isn't something too new, but I get a nice description. A UI color object represents color and sometimes opacity, ... It's been available for quite some time, since iOS 2, so several years ago. It's declared in a file called uicolor.h. So in answer to your question, can't see the actual implementation of this, but I can see the header file and any constants or methods or other things related. Here's what's of interest. The Apple documentation is actually pretty darn good. So if I click on UI color class reference, this program called Organizer loads, but this is just an embedded web page. It's an embedded Safari instance, so the same documentation is available on Google. And just to confirm as much, let me do UI color reference. Sure enough, first hit is on developer.apple.com. And that's the same exact page. So realize you don't even need Xcode to poke around. So let me increase the font size and poke around here. There's a few things to keep in mind when navigating Apple's documentation. And we won't do this ad nauseum. Let's just use UI color as a simple example of how to navigate the docs. It inherits from NSObject. So that's kind of cool. We've seen how to do that in code. This is just the documentation's way of saying it. Conforms to. Conforms to what? What are those three blue words apparently examples of? Those are three protocols. NS copying we've seen. Turns out there's other things, NS coding, NS object, whatever that is. If I clicked on them, I could learn more, but I'm not too interested in that just now. This is part of the UI kit framework, but we kind of guessed that earlier from the UI prefix. Declared in, all right, somewhat interesting, sample code. So this is where I've never been a fan of Apple's code. A lot of their sample projects are way overcomplicated for newbies, so I would generally advise not diving into something like a Quartz demo, which is a fairly sophisticated graphics demonstration, and looking instead to online tutorials or books or the course's own sample code, because I think you'll often find Apple's code overwhelming. But feel free to poke around if you'd like. And now here's some standard vanilla stuff. So some English prose explaining what it is. For some reason, Apple calls methods tasks in the documentation, but tasks just means methods. The ones that are prefixed with a plus means they are what types of methods? Class methods. You can call them without instantiating an object with alloc. The minus symbol prefix means it's an instance method, so you have to allocate the object first. Apple does not exactly alphabetize them. They essentially categorize them into some arbitrary but generally helpful categories, creating a UI color object from component values, initializing. So honestly, Command F will be your friend quite often. When you're looking for something that you remember part of the name but you can't quite think of it, reading through the documentation can be a little tedious because of the arbitrary way they sort, and I mean, there's absolutely no sort order to this thing, as best I can tell. But there's white color. So if we click on white color, notice that it's also a plus, so it's not a property. It's a method that gets passed to an object, message that gets passed to an object, and there's its documentation. And let's consider this as representative of the rest of the docs. Returns a color object whose grayscale value is 1.0 and whose alpha value, which refers to opacity, is also 1.0. So that's the FFFFF that I referred to earlier. Return value of this method is the UI color object, of where it's available, not too interesting. And then we get yellow and some other standard colors. And if we really wanted to, we could mix together any colors of the rainbow that we want, but you get some standard ones out of the box just because it's convenient. Nothing else. So just a couple lines left before we are indeed iOS programmers. So let's zoom back in. This last line before the return statement is important. And you can probably maybe guess what it is. Self.window, make key and visible. So first, what is make key and visible? Not what it does, just what is it? It's another example of a message or a method, a message that's being passed to an object, or a method invocation, to put it differently. So make key and visible. I don't really know what key is, but visible presumably means make the window visible. Perhaps by default it's hidden, much like you might have with CSS hidden divs and whatnot in JavaScript. So it's apparently hidden by default. We want to show it. Key just means make it the key. Make it the important window that responds to the user's key presses by default. Make key window makes it foregrounded effectively. So return, and this is one of the stupider things of Objective-C. Whereas the rest of the world uses 0 or 1 or true or false, Objective-C uses yes or no in all caps. It's just a Boolean value. Return yes means return success in this particular case. Now, thankfully, we can delete the rest of this file because down here is a method. I'll let someone else answer. What's the name of this highlighted method? Too much. You consume too much of the string. It's just UI will resign active. And if you're writing it out, include the colon. But the name of this method or this message is application will resign active. If I actually read the comments, it'll explain in more detail what it does. But in a nutshell, this is a method that will be invoked automatically by the operating system when my application, as implemented in my app delegate class, is about to do what? Resign active state. So it's when the user has hit the button, but nothing has quite happened yet. So that's my way of responding. So think again about JavaScript and DOM events, things like on key down, on key up, on submit, on change. All of these event handlers, very similar in spirit, whereas those event handlers in JavaScript are called on submit, on click, on key up, and so forth. In Objective-C, they're a little more, in iOS, they're named more verbosely, but it's the same idea. These are event handlers that are being invoked for me by the operating system. What's another? Application did enter background. So when the thing has actually been backgrounded. Application will enter foreground. So just before it appears on the screen, maybe I want to update the inbox so that the user sees the current inbox, not the old one, that what might have been the case when they backgrounded it a day ago. Application did become active. So once it's actually running in the foreground, application will terminate. If the user holds down the button and clicks the X on an icon, you do have a chance to do some last-minute housekeeping before they even force quit their application. So these are all hooks into those very low-level operations. Notice that there are comments inside of them, but nothing is actually happening. I can actually safely delete all of them. That won't break the class, because what class does app delegate descend from? UI responder. So if I actually dig a little deeper, it turns out that those methods are probably implemented elsewhere, higher in this class hierarchy for me. So even though the templates that Apple provides often have lots and lots of code, a lot of it just to kind of focus and simplify things you can start deleting, at least if there's no built-in functionality there. And in all of the lecture examples tonight, I've done that in advance. As you'll see, I've pruned away anything that's superfluous so we can only focus on what's core to those applications. So incredibly underwhelming. Before we take a break, let's at least reassure that we can do more interesting things. I'm going to go ahead and rapidly create a new project, single view application, because this time I want a view. I want something on the damn screen. I'm going to call this test2, but we'll come back with more interesting examples. I'm going to uncheck use storyboards for now. More on that to come. I'm going to click next. I'm going to go ahead and save it on my desktop. I am now going to notice, but explain later, a few new files, view controller. That's good. We have some brains for my application now. But also this xib file, pronounced, of course, nib, N-I-B, for historical reasons. As soon as the nib file became an XML file, they renamed it xib, but we still say nib. Now notice nib, or .xib. Ooh, this makes programming look fun now all of a sudden. This loads what's effectively a tool called Interface Builder, although Apple doesn't really call it that anymore because it's embedded right into Xcode itself. This is how easy it's going to be to start making at least the simplest of applications UIs. I'm going to go to my little palette here on the right-hand side and notice that there's some juicy, friendly-looking stuff down here. Label, rounded rectangular button, segmented control, slider, switch, progress view. So some familiar UI mechanisms. I'm going to do a super simple one like label. I'm going to drop it over here roughly in the, let's say, top middle of the screen. I'm going to say hello class. OK, it's still centered. Now I'm going to click the run button at top left, which will launch the simulator. And if all is well, now we have the beginnings of a more interesting application. So let's take a 5-minute break here. We'll come back and actually say how to make that and more. All right, we are back. So the exciting cliffhanger before we took a break was to get hello class onto the screen. But before we forge ahead and reveal just how this magic happens, any questions about Objective-C, UI Kit, or anything thus far? Really? OK. Red rectangle on yours.
It should be on all.
Oh, let me see if I can replicate that. Let's see. How did you get that onto your screen? You have it at the bottom of the UI view?
Yeah.
Yeah, it's a good question. It has to do with hooks. They're similar in spirit to these, which we will talk about, that allow you to drag and drop more easily onto the surface of this object. We don't have much in this. Let's see. Click here. I am not sure where that feature has been tucked away. I will try to replicate it after, and we can look at it on your screen. OK. Yep. That's because when you created your project for single view application, you left use storyboards checked. And we'll come back to that. But for now, I thought I'd simplify and uncheck that if you'd like to refollow those steps. All right, so we are back now with this single view application. And we seem to have a couple of more files. We still have an app delegate. We still have an app delegate.h and .m specifically. But we've got at least 3 new files. And just in case there's even more going on underneath the hood, let's zoom in on these groups, these folders over here. Those files look familiar. I don't think there's anything new in there. The file is called test2 instead of test now, but that's because I renamed my project. So all of this looks familiar. Nothing else is new underneath the hood. And indeed, if we look at main.m, there's nothing new there. It's still called app delegate, and somehow that's kicking off this process. So let's ignore those supporting files. And let's go into appdelegate.h to see what's new here. Let me hide this window on the right-hand side for simplicity. And does anything jump out at you as new in this example versus the empty application we wrote first? Yeah, there's a view controller. So this is interesting. We have 2 properties, not 1. And we needed that original property window just so that we had something to hang on to somehow called the UI window. And it was assigned to that property in appdelegate.m. But now we've got another property, also strong and non-atomic, which for now just take on faith as copy-paste when you declare a property like this. It's apparently a pointer called viewController, lowercase v, and it points to an object of type viewController, capital V. So I don't quite know what that is in terms of iOS's world, but viewController, it's a controller, which was what? In general terms. What's the viewController? What's a controller? Yeah, so it was the brains of the operation. So MVC. So recall one paradigm. Let's see. Let's really give me at least one chance to swipe. All right, so we had this picture over here, MVC. So the viewController in the world of iOS is just the C in MVC. So it's the brains of our application. Now in reality, as you start writing more and more complex applications, you might very well have more than one viewController, more than just one C, and you might have a super important controller that somehow delegates control among other controllers, but it's still the brains of the operation ultimately. So let's dive into the H file, as should be a common technique, to just see what's going on inside of viewController.h. That is very underwhelming. So my viewController class is apparently a child of the UI viewController class, and that's where the story ends. There's nothing going on, at least inside of the H file. So let's take a look at appdelegate.m before we look at that other method file. What else is new here? Well, I'm a little overwhelmed by all the lines here, but I realize that, almost all of this is comments. So for simplicity, let me go ahead and throw away everything that looks uninteresting in this template and zoom in only on the code that remains. Now this first line, self.window, this looks familiar, right? It was a little verbose, but it allocated a UI window, figured out its dimensions, and gave me a pointer there too by storing it in my window property. Okay, so it's something to hang on to, even though we didn't do anything interesting with it yet. Now, what line of code is new in this method called application did finish launching with options? Yeah, self.viewController. So here's something interesting. Even though this application only puts hello class on the screen, this line of code looks new. So self.viewController is referring to what, to be clear? Say again? The viewController property. So self.viewController is the property that was declared in what file? appdelegate.h, exactly. So we're assigning to that property the return value of this expression here. So a little bit of this is new. ViewController alloc. So alloc allocates me a new object of type viewController. Who wrote the viewController class? Apple, at least in the form of the template code, but they seem to have given me the raw source code for the viewController class, as we just saw from viewController.h, so I can take over the brains of this operation. They did not give me the source code for UI viewController, but that's fine, because my viewController class can still descend from it in terms of a hierarchy. It can be my parent nonetheless. So give me a viewController object, and then initialize it with nib name. So here we see the N for nib, for, again, historical reasons. But nib name. A nib is, at the end of the day, just an XML file. But it's not an XML file we will ever look at. You can, but it's just not interesting, and it's rather overwhelming. A nib file is just a file that stores the result of creating a user interface using Xcode by dragging and dropping widgets like I did earlier. I dragged the simplest of them, just a label, but I could start dragging, as you saw, sliders and knobs and switches and text fields and other such things. A nib file just stores that result of all that dragging and dropping so that you can program at least your UI a little more easily. Now, you don't have to program your UI with Xcode in that way. We'll see it and do it a much more manual way. But what this does is it initializes my viewController with the contents of a file called, nib name is viewController. If I read the documentation, I will see that that method, init with nib name, is supposed to look for, by default, the string that's in quotes, dot xib. So that's how I'm linking my code in Objective-C to what we called the nib file earlier, which again I got for free via this template. So that's where my code is saying, give me a viewController and initialize it with the contents of that XML file. So in other words, if I created that user interface a week ago by dragging and dropping labels and text fields and sliders a week ago and saved it, this reloads it into the program's memory. So lastly, another new line, self.window.rootViewController. We didn't have this before because we didn't have a controller. Our program was so simple, there were no brains behind the scenes because it only showed a white screen. But it turns out there is a property called rootViewController whose purpose in life is to serve as exactly that, the most important view controller, the most important C controller that runs the entire operation. Now, how do I know that's the case? Again, you don't have to take all of this on faith. Let me hover over self.window, a question mark appears, and oh, interesting, this is a property called window that's been declared in there. And I want to see the documentation, so let me go to the reference down at the bottom. And now the reference for the window has a whole bunch of stuff. And if I skim, root. Mine is the only phone connected to the speakers in the room. Okay. So if I skim through here, properties window. Oh, you know what? I'm in the wrong place. Because if this is the UI window, I'm currently in the UI application delegate reference, which just means, again, my app delegate implements that thing. So what I actually want to go to, let's do that trick from earlier, UI window. And there, sure enough, let's make sure we get the iOS version and not the macOS version. So let's add iOS there. UI window class reference. And now if I scroll down, tasks, which again are methods, key window. We haven't seen that before, but it sounds like the buzzword we saw earlier. And aha, there is the formal documentation that says a UI window, which is what my window property points to, has a property called rootViewController. And if I read the documentation, the rootViewController provides the content view of the window, assigning a view controller to this property, installs the view controller's view as the content view, This is how you specify who the brains are behind your application. And it's going to be specifically an instance of my view controller class. So the only two lines here then that are new are this. The only files that are new are the three up there. So there's one file we haven't looked at yet, which is viewcontroller.m, so the implementation of this class. So looks like, fortunately, just some template code. And in fact, I can delete all of this. So let's see what's in here of interest, potentially. I've got a @interface sign at the top, view controller, open parens, and then end. This feels weird, because where do I usually see @interface? So in the header file. But I already saw this in the header file. Just to be clear, if we go back to viewcontroller.h, I already have @interface viewcontroller. So what is this doing here? What's that? Yeah, it's sort of a private interface. It's using what appears to be a, what's the buzzword here? A feature of the language known as a category. Yet, turns out, and this was something added somewhat recently, you can have nameless categories with no name, open paren, close paren. So this is a category, which just means here, hey Xcode, here comes some more methods that are associated with the view controller class. Now, it turns out this is just boilerplate code that Apple's provided, a starting point. There are no such methods, but if I wanted to have private methods that I don't inform the world about via my header file, where do I put them? Where that blank line is, right there. But functionally, this isn't doing anything for me. It's kind of overwhelming me, so I'm just going to get rid of it with no effect. @implementation is what I did expect to see in this file. And now there's two methods that we did not see before, and they're not arbitrary. Turns out that view_did_load and did_receive_memory_warning are methods defined by Apple in what class? They're not in my class, because, right, if I go to my header file, I made no commitment to implementing those two. So where do view_did_load and did_receive_memory_warning come from? Yeah? Yeah, it must come from some parent or ancestor class, and I'm going to guess it's from UI view controller. And if we actually looked at the documentation there, maybe followed some links, hopefully we would indeed see the definitions, or the declarations of those methods in the documentation. Now, what do? Thankfully, there is an upside to the verboseness of all these method names. View did load, that method is invoked when the view did load. Now, what's the view? Just to recap. What is the view with respect to an application? The interface. So when some stuff came up on the screen, what method gets called? That one. Why might that be of interest? Well, once the stuff has been painted on the screen, the text fields and the sliders and whatnot, maybe you want to start updating the values. Maybe you want to start bouncing a ball around once the UI has been generated for your game. Whatever you might want to do could happen at that juncture. And so Apple's comment here says, do any additional setup after loading the view, typically from a nib. So this just means especially if your interface came from a serialized XML file. So just a nib file that you created with the drag and drop interface we saw briefly earlier, you can, from this method, do more stuff once that UI has been reconstructed into your program. Now, super, for those unfamiliar or less familiar, what's that line of code doing above the comment? Yeah. Exactly. That line of code is passing the viewDidLoad message to the super class, which is the parent object of this particular class. Now, this too is a convention, and if you read the documentation, Apple will say, if you implement viewDidLoad, you had better remember to call our version of this method in case there's some important stuff that happens in this class hierarchy, after which you can do your thing. So I'm fine with deleting the whole method, because if I delete it, it will still exist where? In the parent class. What I should not do is ever get into this habit, which means my object might not be properly loaded if I have not called the parent class's implementations of the same method. So again, you know that really by convention and from reading the documentation carefully. But viewDidLoad, don't need it. Did receive memory warning. I'm not going to need this one either, so I'll hit delete. But you can probably guess what this means. If your iPhone has a limited amount of memory, which it does, and you start loading lots and lots of apps, and you've gotten a lot of mail, loaded some big web pages in Safari, and your phone is running short on RAM, this message might get sent to your game saying, hey, you better calm down and give up some RAM, especially if you've been a little sloppy with your coding and have been allocating and allocating and allocating objects that you just don't need. This is your application's chance to give memory back, because if you don't cooperate and if you don't try to respond to this programmatically, what do you think Apple does to your program while running on the user's phone? They just kill it. After some number of seconds, if your application has not freed up some megabytes per Apple's request, they kill it in the interest of a good user experience. But if you've ever wondered why applications might just disappear from the screen, could just be that it's really crappy code and they had some memory error and just the thing crashed and Apple just terminated it for that reason. Or it just got memory hungry, didn't adhere to this admonishment, and so iOS killed it for that reason as well. Au contraire. So it is very easy to start allocating objects, maybe keeping them in around an array that you actually don't really need, or even in the context of the upcoming project, which we'll talk about in lab on Wednesday, you'll have an opportunity to load tens of thousands of English words from a dictionary file that we will provide to you. And it's very easy to keep those around in memory in the original data format, and yet you don't really ever need it again. And if you don't think about when you actually need data, or you don't actually decide, you know what, I might need it, but hell, I'll just reload it from the file system when I need it, you can start churning through more memory than you actually intend. So it's gotten easier to deal with memory management thanks to that ARC feature, automatic reference counting. We don't have to worry about freeing memory as much, but you can absolutely allocate more memory than you really, really need. Yeah? A statute of limitations in what sense?
Like, there's only so much relying on ARC where you can still run out of.
Absolutely. So ARC will free your memory when it determines that you don't need it anymore. But it is very, very easy for me to declare a pointer in a certain way and tuck it away in my app delegate and just keep it in perpetuity. And the operating system will never know if I might need it, because this reduces to something known as the halting problem. If you're familiar from a theory class, you don't necessarily know if and when certain code fragments you wrote will get called. And if those code fragments might eventually touch that object, it can't necessarily be freed. So you can very easily contrive scenarios where you consume way too much memory. And as an aside, you can simulate this. Thankfully, you don't have to just cross your fingers when developing iOS apps that you'll see this problem before you ship your program. you can go up to hardware and simulate memory warning, and you can force the simulator to send that message to your phone so you can figure out in advance just how well you're handling the situation. Let's see, another hand went up. Yes? Mm-hmm. Good question. So whenever in doubt, let me hold option. Let me go ahead and click on the method name, and here we have returns a newly initialized view controller with the nib file in the specified bundle. So if I keep reading here, if you specify nil for, let's see, where's the nib? So if we read long enough, we'll get to the discussion of the bundle. The bundle you can think of as a program's folder. You can have nibs in different bundles and different folders effectively, which can be helpful for things like iPad UIs versus iPhone UIs and the like. Nil in this case just means get me the default, which is right there and can be found by its name. Good question. Can have to do with localization too, if you've got an English version, a Spanish version, both of which you created with the drag and drop interface. Yes?
Can you actually call parents class?
Yes, because you could. Actually, let's see. Super. Good question. You can definitely do the latter, implementing a method that does that in the parent class. I don't think you can access the grandparent class directly. You need to have some kind of preparation in advance with that parent class. Good question. All right, so wonderfully interesting maybe, but at the end of the day, we still made a pretty crappy application that just does this. But still, there's some kind of communication now between that nib and my code, and we saw that by way of the loading of the nib. But this is a purely unidirectional program. When I run it, all I see is text before me. There's no means of interaction. So let's start to make something more interesting, a little more from scratch, that allows me to interact with the application itself. So I'm going to go ahead and close that one, create a new project, so not a new file, a new project, single view application, and this is generally where I'm going to start now, because with single view application, as you saw, we get a view controller and the nib file and the header file, and we get some additional wiring in the code, but I could absolutely have recreated that simple little hello class program by starting with an empty application and going to the file menu and saying new file and gradually adding back all of the individual files. The headache that arises quickly if you start doing too many things from scratch is you have to reconfigure some of those lower level settings that you just get for free with some of the templates. So I would start initially with the more useful templates, and only once you get comfortable, try recreating some of these things, as we may do in lab this week, from scratch and reconstructing what someone at Apple has already done for us. So single view application. I'm going to go ahead and call this thing nib1, just my first example involving a nib that I'm going to really give some thought to. I'm going to turn off storyboards just for now to keep things consistent with that last story. Click next, save it wherever. And now I have essentially the same exact application I had a moment ago. Sure enough, if I click on my nib on the left-hand side, I just get an empty iPhone window there. So now let's do something a little more interesting. On the right-hand side here, there's a whole bunch of Photoshop-like options, whereby you can start tinkering with the WYSIWYG, what you see is what you get, interface, the drag and drop interface. And this is frankly a little overwhelming at first glance, and I don't think I've clicked on 50% of these over time, but there's a few that I occasionally use if you're actually using Interface Builder to create your UI. One of them is surely the Objects submenu down here, where I can drag and drop things like labels. I did that before. So let's start there. Let me scroll down, and let me get a text field. I want to write an application, I think, that allows me to type in my name, hit enter, or click a button on my screen, and be greeted, hello, David, or whatever name I happen to type in. So some dynamism that we just haven't had to date. So I could, of course, just do this, label, hello, David, but as we saw before, that is not really the point here. Well, let's actually have a text field that the user types in. Let's see a keyboard pop up and actually interact. So let's delete that. And again, I'm clicking and deleting just like you would in Photoshop or GIMP or whatever graphics program that you might have tried in the past. So give me a text field, and I'm going to notice a few things happen. Much like in Photoshop and other programs, you get some suggestions as to where to put it relative to where the glass is and how thick a human finger is, but you can ignore that, but I'll just do that. I'm going to now click and expand it. So here I am programming. All right, and now I have this text field, and now notice up top, there's a whole bunch of these icons. Frankly, after several years, I still don't remember what one is what. But if you hover over them, you get little tooltips. So this one here is called the Identity Inspector. We'll click on that in a moment. This one's the Attributes Inspector. This one is the Size Inspector. And this one is the Connections Inspector. So let's start with Attributes Inspector. So that's this one here. And notice I can do a few things. I can change the color of this text field, the font size. How about some placeholder text? Just like in HTML5, you have a placeholder attribute. I'm going to put name here. And now notice if I look at my GUI, I have a grayed out word name. So that's nice. It's a nice little enhancement. How about the background? If I click on the gray background, notice over here on the Attributes Inspector, I can choose a different color. So that's kind of interesting. Let's click Other, zoom out so I can see it. Choose the little crayon things, and let's change it to white. So now I have a UI more like the one I got earlier for free by just using the empty application. And now I need a button to submit. So where's that? I'm going to drag and drop the button here. That's where Apple recommends I put it. I'm going to double click on it like in Photoshop and type Go. But notice I could also be a little more anal and go over here, and I could manually type that here. I can change the style of this button. Let's see, instead of a rounded rect button, I could do something like an info button, but that's not what I wanted. That's that little eye icon that you see in, I think, the stock application. So let's undo that. Long story short, I could start tinkering and change the aesthetics of this. But functionally, that just will get boring quickly. So let me wave my hand at the remainder of the attributes that you can tinker with. But it's the kind of obvious things, size and weight and other things. So what else might I want to do here? Let me go up to the Identity Inspector, which is this icon to the left of the Attributes Inspector. And I'm not going to change anything here. But notice that there's a hint of the relationship between this drag and drop interface and code. I've highlighted the text field that I dragged and dropped. I've gone to the Identity Inspector, and Xcode is hinting to me that the type of object I have effectively instantiated or allocked by dragging and dropping is what? It's apparently a UI text field. So we'll see in a bit, I could actually write lines of code that alloc a UI text field, and in code tell it to go to 10 pixels from the top, 20 pixels from the left, and I could actually do all of this programmatically. Xcode's purpose in life is just to simplify this process, at least for newbies early on, to help get you started quickly with a more user-friendly UI. So unfortunately, I've made my UI, simple though it is, but it doesn't actually do much. Let's see what it does do. Let me go ahead and hit the play button. That'll spawn the simulator, assuming I've made no syntax errors. Pretty good so far. Looks like I expected. I'm going to click on Name. And notice I get the keyboard for free. Because it's a text field, Apple knows that when you give focus to it by clicking or touching on it, if it were an actual phone, they pop up the keyboard. I can start saying something like D-A-V-I-D. Notice it's going to try to do autocorrect for me, so that's kind of a nice feature. And now I click Go, and of course nothing happens, right? Because what should happen? We haven't told the program what to do. So we have to somehow now associate that button and that text field with actual code. So where might we do this? So henceforth, even though you could put code in the app delegate, and in fact, let me just clean this up and get rid of all superfluous stuff. Even though you could put code in the app delegate, in the header file or the M file, you typically won't. You'll typically immediately hand off control from the app delegate to a view controller, a root view controller, and isolate your code there. There's some cases where that's not going to be the case, but for now, think of a breakable rule of thumb that you should start writing all of your code in the view controller and not start embedding stuff in the app delegate, partly by convention here, per the MVC paradigm we just mentioned earlier. So what should I put where? So if I'm going to put almost all of my code in the view controller class, that means it should go in the H file and in the M file. But currently, these files look like this in the H file and in the M file, which looks like this. And honestly, this is really uninteresting. I'm going to get rid of this. I'm going to get rid of the private category, the semi-private category. I mean, this class literally does nothing. But I need a way of somehow linking this class with that user interface. I need some kinds of like extension cord that wires the nib, the UI, with my code. And so the mechanism that Apple offers for this is something called an IB outlet for interface builder outlet. And you can kind of think of it as a socket into which you can plug a cable to somehow wire these two things together. So the paradigm for doing that essentially boils down to declaring properties. So what I'm going to do in my viewController.h file, inside of my class declaration here, I'm going to go ahead and start typing property. And I'm going to know in advance it's going to be non-atomic strong. In the future, we'll think harder about that. But for now, let's just go on faith and say that it's non-atomic and strong, or strong non-atomic. The order does not matter. IB outlet, and then UI text field. And let me close this window over here to give me some more room. Star text field, semicolon. All right. Does this look like a valid declaration? Exactly. So this is a bad sign. If I click at that expected semicolon at edge and declaration list, it actually doesn't quite know what I'm talking about here. Let's try to fix that. IB outlet, resave, problem goes away. When in doubt, simply changing things in Xcode doesn't necessarily mean Xcode will notice, but generally saving the file will mean it will reanalyze your code and get rid of any warnings or errors. OK. So what does this mean? Well, a property is just a means by which we can synthesize a getter and a setter and give us dot notation access to some instance variable. By convention, what is the instance variable going to be called that is behind the scenes for this property? Anyone recall or know? This used to be more explicit, but more recent versions of iOS just kind of do this for us. By convention, what Apple... What's underscore text field? Yes. So by default, what Apple does these days is if you declare a property called text field, they will create for you a UI text field star underscore text field instance variable for you inside of the object. But we shouldn't have to know or care about that because the property gives us getter and setter access to it. But just FYI. OK, so what is an IB outlet? Well, what's interesting is because I typed IB outlet, notice this little circle that appeared here. Let me get rid of IB outlet, hit save, it goes away. Let me put it back, save, and come on, comes back. So notice, this is kind of cute. If can I do this here? Damn it. I need to have two windows open. We'll come back to why that's cute. All right, so how do I actually now connect? And that represents the sort of socket that I alluded to earlier. How do we actually connect that line of code to my nib file? So we can do this in a couple of ways, but what I'm going to do is first, let's say, go to my nib file over here, and I'm going to expand this window here. And this is a little complex at first, but now I am in viewController.nib, which gives me my user interface that we defined earlier. And now notice on the left-hand side, we get this little cheat sheet of placeholders where I have the objects in my view. Now, what does this mean? For now, notice that, and I'm going to just drag this over here so they're side by side. This big rectangle is itself a UI view. Where did it come from? It just came with the template. I got a default UI view rectangle by default. I then started dragging and dropping stuff on there. Case in point, I'm going to delete the go, and notice the placeholder at top left is about to disappear. So that's where it came from. So if I go back to my little menu on the right-hand side, and I grab myself another rounded rectangular button, drag it here, notice it reappears under view. And that's because this is indeed something akin to a canvas. They gave me a blank canvas at first. It was gray. Then I made it white. And then I started dragging and dropping different layers or objects on top of it. And that's the hierarchical representation of that. Constraints we'll wave our hands at for now. That just has to do with supporting devices of different sizes, like an iPhone like this, an iPhone like this, or an iPad. But those are given to me by default just to help me out. And now up here is something called files owner and first responder. We'll ignore first responder for now, but files owner refers to the class that has ownership of this nib. So per our discussion earlier, which class owns this nib or uses this nib to load its views? The view controller. So really, that icon, which is like a yellow cube, is just an iconic representation of my class. It just represents my code. Now, why is this useful? Well, notice if I click on Control here and then start dragging, notice that this little, we'll call it an extension cord, starts to appear. This blue line starts to appear, and it wants to lock on to things over here. And I'm going to go ahead and hover over the text field, and I'm going to let go. And now notice Xcode tells me that I have a few outlets that I can plug this blue cable into, one of which is called text field, one of which is called view. The fact that there's a little minus sign there means something's already plugged in there. Just don't touch it. That's what came with by default when we got this whole view. But text field looks familiar, right? That was the name I gave to what? That was the name I gave to the property that I typed out in the H file. So simply by selecting with my mouse text field, I now get some kind of association. The line goes away, but there's some kind of association made between the file's owner, aka viewcontroller.m or .h, and that particular widget inside of my view. It's like I've plugged one into the other. So what does this really mean? This means that when I run this program, my property called text field, which is of what type? It's a pointer, which means it's meant to store an address. So what I have just done with this drag and drop interface is I've told Xcode, when you load my program, and when you load this big rectangle, and you start plopping the text field there, and you put the go button there, the last thing I need you to do before you hand control to my application is figure out what is the address in RAM of that text field that you dropped there for me, what is the address of that button that you dropped there for me, and put the address of the former, the text field, where? Inside of the property that I declared called text field, which is a 64-bit chunk of memory in which I want the address of that text field. So again, all Interface Builder is doing for us is kind of simplifying, dumbing down, if you will, the process by which I can create a user interface, and it is going to do for me the process of allocing that UI text field, figuring out what the return value of alloc is after initializing it, and then putting that 64-bit memory address into my property. And that is, again, what the dragging and dropping and that blue line have done for us. It saved me the trouble of doing the assignment operator somewhere in code to figure out the address of that UI text field. So what's the implication of this? Well, the implication is we can do one other thing. It's one thing to have a connection from my code to Interface Builder. Why is that useful? It means I can probably programmatically ask the user interface for what? The value. So if the user types something in, much like in jQuery or JavaScript, you can ask a DOM node, what is its dot value? Similarly now in Objective-C, can I programmatically ask what is the value of what the human typed into that text field? Because I have a connection from my code to the text field. But that's not quite enough to make an application that allows me to type in my name and then see a prompt on the screen. Because in order to inform the program that I have typed a word, what's the human convention? To hit like enter or hit the go button. So I somehow need a cable going from that go button back to my code. So the opposite of an IB outlet is what we'll call an IB action. And I declare that in my H file as follows. Dash, because it's going to be an instance method, IB action. And now notice Xcode's trying to be helpful. Let me do that again. IB action. Notice that it's encouraging me to give the selector. Selector is a fancy way of saying method name, colon ID sender. So we'll come back to ID sender in a moment. I'm going to go ahead and call this something somewhat arbitrary, go. This is the method I want the UI to call when I click that go button. Now ID sender, this it turns out is just a convention now. IB actions, if you read the documentation, state that when an IB action, aka method, is called as a result of a user doing something with the user interface, that method, called go in this case, but it could have been called anything, is passed a pointer to what, do you think? To the object that was touched on the screen. So it's a way of potentially having multiple buttons, for instance, all invoke the same method, but I can somehow identify which one of them was actually touched. Maybe those buttons have different meanings on the screen. In this case, it's moot, because I just have one, but if I had multiple, that would be useful. What is an ID? It's a data type, recall. Yeah? It's not necessarily a void pointer. It is a pointer that can be nil. So ID is like saying void star, for those of you who knew C or C++ before, but it's a pointer that can also be nil. So this is sort of the common Objective-C way of saying this is a pointer, but it might be nil. It might not be a valid value. OK, so I'm done with that. Oh, and now notice, here's where it got useful. Because I have this circle now, notice it's filled in. That's because I've plugged something in to the outlet with that little blue line. All right, so IB action go. All right, I'm really eager now. I'm going to go ahead and click run here. All right, I'm going to see my UI in the simulator. And notice for some reason the latest version of the iOS simulator is slow to start, but here it is now. I'm going to go ahead and, very exciting, DAVID, go. Why is it not working? Yeah, I didn't link it, right? All I did was declare a method that happened to be called go, but I made no programmatic connection between that method and the UI, and indeed, the little cute circle here is still empty. We haven't wired those two things together. So let me go back to my nib file. And actually notice, Xcode's pretty good. Xcode underneath the hood uses a compiler called Clang, whose error messages are pretty decent and pretty human-friendly. Incomplete implementation, it's slapping me on the wrist for having done exactly what we identified as the problem already. So if you get this here, notice it took my files away. Not a problem. See the little folder icon at top? Click that, and I'm back where I expect to be. Let me go to my nib file. And now notice, this time, I want the arrow, the blue line to go in the other direction. I want the button to be linked to my code so that messages can be sent from button to code. So again, I'm going to hold Control. I'm going to click on Go. And now notice, little blue line starts to form. And it wants to cling to a few things, but I know just intellectually that this belongs tied to my class where that IB action was defined. So if I let go over files owner, notice that the events that I can wire this into is go. And here, honestly, Apple's just inconsistent. They call it an IB action in one place. Here they call it a sent event. It's the same exact thing. So I'm going to click go. And that linkage has now been made. Indeed, if I go back to my code, notice the little, notice in the H file, the little circle has been filled in. And I can confirm as much now if I go to the nib file and I control-click on this button, notice that it turns out there's more than just the default blue line that can happen. Notice there's a whole bunch of events that a little itsy-bitsy button like the go button can send. The one that's inferred to be the default when you just start clicking with control and dragging and creating a blue line is an event called touch up inside. That's like on key up. It's on touch up. So as soon as my finger comes up, this event is going to get fired. But clearly there's other ones related to dragging and other things. But that's the one that Xcode does by default. Suppose you didn't really know that or you wanted to change it or you just goof. Notice I can undo this. Oops, that was a mistake. But no worries. I can zoom out. And now notice I can go to touch up inside. The little circle becomes a plus. And if I click there and notice I can drag to files owner, choose go again. So two different ways to now do this. And we'll give you a third if I now delete that. So the blue line is now gone. Now I can enter a different mode in Xcode, and this screen is a little small, so this won't quite do it justice. Let me hide the view over here. And notice, if you just click around, you can do no wrong. You can just hide things by clicking some somewhat obvious buttons. I'm going to go to this little butler icon in the middle, which is called the, Assistant Editor. And if I click this, notice that I get a split screen. Unfortunately, my screen's somewhat small, so this is somewhat underwhelming. But if you have a nice monitor at home, this is compelling. Notice now that it's a butler icon because it's the assistant and it's trying to be helpful. When you click that icon, Xcode will typically open in another window the file that it statistically thinks you're likely to care about next. And in this case, it got it right. I'm in my H file. I want it to be in my nib file also, because now, notice these cute little circles finally have some applicability because I can see them on the screen at the same time. So if I click on Control here and drag down to here, it goes the other direction. If I click on the plus there and go to my button here, I can actually wire it to go in exactly the same way. So many, many different ways to do this. Let me go back to the simpler code window. I personally find it easier to just control-click on the icon and then just start dragging and dropping. Let go, choose go. Everything's now wired. You can verify as much by clicking Control, looking that touch up inside is referencing files owner's go method. And conversely, if I go to files owner, click Control, zoom in here. There's some stuff I didn't do. Apple did some of this, but notice that text field is linked up to the text field name, which is exactly what's in the UI. So again, 3 different ways to now wire this thing together. All right, so now, okay, really excited now. I've got everything wired up bidirectionally. I'm going to click run. It says stop nib1. That just means the simulator is already running. I'm going to ignore that and just tell it to restart the simulator with my new code. Everything's wired up. Very excited. Type in the AVID, go. Damn it, my first crash. So this is the debugging window down here. Anything that looks that unintelligible means you screwed up somewhere. So what did I do wrong? Yeah. I didn't implement the method. I declared to the world I am implementing a method called go, and then I never got around to implementing it. So it's like I've referenced an invalid pointer, effectively. So let me zoom out. Where do I, oh my god, what the heck? So there's your threads we promised earlier. I'm going to go back to the folder view, because I know what the problem is. Where do I solve this problem? Yeah, the .m file for my view controller. So first let me go to my h file. Let me go ahead and copy the signature of this method just to save myself some keystrokes. Let me go to viewcontroller.m, and notice Xcode knew and warned me in yellow, incomplete implementation. So that's another advantage of using the h file and promising to implement something. You can now follow through on that. Let me go ahead and start implementing that here. Question?
Is there an auto-suggest keyboard shortcut? Since it says incomplete implementation, I know that like in Eclipse with Java, it'll sometimes give you an auto-suggest.
That is a good question. Let us see. Let's click on the arrow, incomplete implementation. Let's see if we go up here, incomplete implementation, method definition. There we go. So short answer, yes. And I found that by clicking on the little yield sign here, the exclamation point, digging down through the hierarchy, and then Xcode reveals some more explicit information. Yes?
Why doesn't it throw a compilation error if you don't specify that?
Because that's a good question. It is not a, well, so we could turn on certain levels of warnings to tell the compiler, don't let me compile this. By default, it will assume that I know what I'm doing. Maybe I'm linking in the implementation of that method in one of those libraries that we saw earlier. So maybe buried deep inside one of these frameworks is an implementation, and I'm just making a commitment to the linker that those bits will appear eventually. Short answer is we could change that behavior if we wanted to. By default, it doesn't protect us from ourselves. Yes?
Is that string and hexadecimal just like a location where?
Yes, these are all hex values, and presumably, I don't know for sure here, refer to memory addresses probably inside of this dynamic library, which is code that Apple wrote that's been compiled elsewhere, I'm guessing. RJ.
If you scrolled up in there, would there be any useful information at all?
There we go. So yes, it's a little hard to parse visually, but terminating app due to uncaught exception, NS invalid argument exception, not helpful, but this gets more helpful. Go, unrecognized selector sent to instance such and such. So this means exactly that. You passed a message to an object, and that message, that implementation was not actually there, even though you promised that it would be. All right. So easy fix. Let's go ahead and in my M file, start implementing this. And let's keep this super simple. I just want to sanity check that I'm doing something right today. So I'm going to call nslog of quote unquote here, just to prove to myself that this code's getting called. But this isn't quite right. So a couple things wrong here. I haven't done something right here. Oh, and I'm also in the wrong file. So, all right, stupid Xcode. So even though that's highlighted, I'm not actually there. Let me click on the M file and now put this where it belongs. But there's another error. Yeah, where do I put an @ sign? Okay, in front of the first quote mark, but why? That looks like a string already. It's quoted. It's not an NS string. So an NS string is a special string object. It's a class construct that means there's more to this string than just a sequence of characters. It's not a char star from the world of C. It's an actual Objective-C object. So nslog, if you want more information, click on option, click the question mark, and you can read more about it. But again, it's like printf, but it prints to a standard place. And that standard place for now is going to be down here. This is also useful if you're programming the app onto the phone. You can actually connect the phone to your computer via USB cable, and you can actually see the NS logs of your application running on an actual device via the same mechanism. Generally, though, you should remove all of these things before you ship your product. Otherwise, anyone can see your debugging messages by plugging their phone into like iTunes and watching some of these messages, or the Xcode counterpart. OK, so what I'm promising here is that when the go method is called, it's just going to print to the log at the bottom of the screen here with a bunch of exclamation points. And that'll be progress, more than we've had thus far. So let's run this with the play button down here. OK. DAVID, go. Woo! Finally, I'm programming for real. So it's not that interesting. The timestamp's changing, so it's happening again and again. But of course, I'm not actually getting the value that's in that text field. So we need to go one step further. So how can we go about getting that value? Well, let me try how best to do this. Let's try this. So hello, comma, how do I put a placeholder in for a string that I'm going to insert later? Yeah, so %s, %@, if it's going to be an NS string. So I would have figured out the hard way if I got it wrong, and it would give me a little red flag. So hello here, close quote, comma. Now I need a way of getting at my name that's been typed in by the human programmatically. So recall that we have in my .h file a property called text field. How do I get access to that property in code? What do I type? So yeah, but typically self.textfield. And notice Xcode knows about it, so it's going to autocomplete for me. And then how do I get at the value? Because text field's an object. I'm actually not sure. So I could read the documentation, but I've read it in advance. And if I start autocompleting here, it turns out that a UI text field object, if you read the manual, has a property associated with it called text, whose data type is, apparently, an NS string pointer. So it's a string. So I'm going to go ahead and just do self.textfield.text, close paren, semicolon, save, and all those errors went away. So this is a very poor man's approach to making an application that dynamically says, hello, David, or whoever I type in, albeit to the log down here. So let's go ahead and clear the log by clicking this little clear button. Let's rerun the program at top left. Here's the program. I'm going to go ahead and type in DAVID, go. All right. So no one else besides me with a USB cable can see this, but at least I'm programmatically accessing the name. And if I change this to, let's say, Rob, notice that now we're seeing Rob's name on the screen as well. Question over here? All right, but we can do better, right? This is the horrible, horrible iOS application, or prob. All right, so let's see how we can do better. So let's borrow some of the same constructs we've been relying on thus far in the language and do something a little more interesting. I'm going to go ahead and first, let's say, declare an NS string pointer called s. And I'm looking at my cheat sheet here so that we produce now live will actually match the sample code that you can download and play with later so that we get this right. And I'm going to declare NS string. And it turns out you don't always have to do alloc and init. A lot of classes, NSString among them, have convenience methods that do the alloc and the init for you. And this is one such method. String with format is a message I can send to the NSString class. It's a class method, and I can very quickly get back a string formatted in a certain way. And I'm going to do hello, comma, %@, close quote, and then I'm going to dynamically plug in self.textfield.text, semicolon. So to recap, what's going on here? On the left-hand side of the equal sign, what is happening? Someone. Yeah. Creating a pointer, 64 bits of memory. It's going to be the address of what kind of object? And a string. Am I instantiating an object? So not yet. Not until the other side, the right-hand side, at which point I'm apparently calling a method called string with format that if I read the documentation will tell me that it's a class method that returns a pointer to an NSString object constructed per that format string. So what do I want to do with this? Well, Xcode, if I click on the exclamation point, it's an unused variable s. I've not done anything interesting. So let's do something a little more sexy. UI alert view. And for those of you with iOS devices, this will look familiar. Pointer, I'm going to call it an alert. And now this is going to look a little messy until I tidy it up. UI alert view, alloc. And now I'm going to init with This is one hell of a method. All right, so trivia, what's this method called? Okay, init with title, message, delegate, cancel button title, other button titles. Okay, so it doesn't always read like a sentence, but that is the name of the method. So it's like a method really with multiple arguments. All right, so let's see, init with title. What do I want the title of this thing to be? Well, let's say finally, close quote. What do I want the message to be? How about S? Because I took the time to construct S in advance. Message delegate. I don't want a delegate yet, so I'm actually going to change this to nil for now. We'll come back to that and what it's doing. Cancel button string. So cancel button string is essentially the dismiss button. So I'm going to go ahead and call this thanks. And other buttons title, I'm going to go ahead and say nil. And other buttons title means if you want more than just one button, this is how you give an array of buttons 2 and 3 and 4 and so forth. Semicolon, save. Okay, why is Xcode not happy with me now? I haven't used it yet. I've used S now, so I've solved one exclamation points issue. But if I click on this, it's going to tell me alert is not used because obviously I've not used it. Now this is a mess. It's hard to read. It turns out if you start hitting enter in your code, what Xcode will do is rather anally line things up with the semicolons, as is the convention stylistically in Objective-C. So the IDE will do that for you. And this is, though strange looking, it's a lot more readable than a line that wraps and wraps and wraps. So we'll leave it in this fashion. All right, now what do I want to do? I don't know. I don't remember, but no problem. I know I have a UI alert view object. I'm going to go ahead and click option, get the question mark. Okay, the documentation's a little sparse here, so I'm going to click the class reference. And now what can I do with the UI alert view? Well, there's the method that we described very verbosely earlier. Turns out there's some properties, delegate, alert view style, title, message, visible. So we've seen hints of some of those existing. Add buttons with title, number of buttons. What do you like so far? Show. All right, so let's see what show is defined as. Show. So displays the receiver using animation. All right, so it's a really complex way of saying show the alert view. So let's try that. This is an instance method, returns nothing, so I just have to send a super simple message to my code. So I'm going to go on my new line here and say, how do I send the show message to this object? Just alert show, right? All right, so let's see what now happens. I'm going to click run. Build succeeded. I'm going to go ahead and type in DAVID, and here we go. Go. Ooh, all right, so now it's a more respectable iOS app. Finally is the title. Hello, David is the string S that I passed in as the message. Thanks is the default cancel buttons icon. Or text rather, and if I click that, it indeed goes away. So I can be a little more anal here. I'd like to make this a little sexier. Like when I see that prompt, when I click go, why is the keyboard still there? Right? Like you're seeing it through the translucent button. Let's clean this up. And I would only know this by Googling around a little bit. But what I'm going to do here before we actually display that alert is I'm going to do self.textfield resign first responder. So this is instructive, if only because we've seen this buzzword responder before, first responder, the guy to respond to like a key press. Well, how do you say, I'm done responding? How do you put something away? Well, if I send this message, resign first responder status, to the text field object to which I have a pointer in that property that I declared earlier, I can tell the keyboard, go away. Like the user gave focus to the text field, this effectively blurs the text field. And again, it's not as simple as focus blur. I'd have to read the documentation to know what the message is called. But if I try this now, notice it's a little sexier. DAVID, go, and it goes away because it's resigned its first responder status. If I give focus again to the text field, it comes back, and it now goes away. So there's a bug, though. If I go up here and I type in prob again and hit enter, or even physically go down here, this feels unnatural, right? I shouldn't be forcing the user to hit go, even though they have a return key on the keyboard. So how do we go about capturing that? Well, who might know if and when return is entered? What do I want to wire to what, do you think? Yeah. Yeah, so previously we wired the go button to the go method, but we didn't wire the keyboard, or the text field rather, to that same method. But the text field should surely know when one of its buttons is pressed. So let's see if we can find that. Let me go into the nib file. Let me go ahead and control-click on the text field. And oh my goodness, so many different things. And did end on exit, editing change, editing did begin. Unfortunately, if you just rely on the default by clicking control and dragging, you don't get the right event. But what I'm going to do here is I think the one I want is did end on exit. And again, completely unintuitive, but if you read the documentation, you'd see that defined. Let go, select go, and let's see if I remembered right. All right, if I click run, boot this up, I'm going to go ahead and type in RJ this time and enter. Ah, nice. RJ. Let's do it again. RJ, no periods. Click enter. Finally. And it actually worked. All right, so how did I know this? Well, honestly, it's really by trial and error. Had I done it the other way, first, let's control click. Let's get rid of the X there. Let's just do the default and click and drag, files owner, choose go, on faith, good to go. Not quite, because if I now click here, notice that it's editing did end is the event that's assumed to be the default by Interface Builder, which is not correct. The one I used a moment ago was did end on exit. Again, completely unintuitive, and there's a slight distinction. Editing did end is what gets fired when you take focus away from the text field, but the catch is that hitting enter doesn't technically take focus away. What happens when you hit enter is an event called did end on exit. And I mention this because honestly, the first experience you'll have hands-on in lab and with the first project, there's all these stupid little things that are very easy to trip over, even when you have a super simple application. And I can't emphasize enough when first acclimating to this to really just kind of retrace your steps, go back to the sample code from lecture, figure out what's different between your code and, say, the lecture code, and you'll find that it's just these little tips and tricks that you'll stumble upon so that you don't make those mistakes again the second time around. Yes? Okay.
Would it get executed immediately?
Ah, very good question. So let's go back to my viewcontroller.m. If I had code executed right here, would it get executed immediately? Short answer, yes. So we can actually think back to our discussions of AJAX. This is an asynchronous call, which means the message show is sent immediately to the alert object, but the next line of code will immediately execute. And it turns out that that message box may actually take a split second to actually appear. So if you want to actually respond to the dismissing of that text, of that alert view, you have to adopt something known as a delegate and use a protocol of sorts. And we'll come back to that in just a moment, and that's, again, much like AJAX, these are asynchronous operations. And we'll have to inform the class if we want it to tell us something in return. Other questions? So let's propose a cliffhanger here. Suppose that the functionality I want to implement next is when I type in something like DAVID and click go, I like the keyboard going away, I like the message then coming up. What I don't like now, anal as I'm feeling here, is that when I click thanks, I don't get the keyboard back. It still says David. This is really kind of a sloppy application. I'd really like focus to be given back to the text field. I want to see the placeholder text again, and I want my cursor flashing there for the next round of this game. So in other words, we need now, per your comment a moment ago, we need some way of having the dismissal of that alert view window signal to my code to do those cleanup steps. Give me the keyboard back, give me focus back, delete David, and start anew. But let's go ahead and take our second 5-minute break here, and we'll come back and solve that problem. All right, I know it's late, but we're almost there, and this next stuff will be amazing. But it will make you better at this. All right, so we are back. So where did we just leave off? So we have an implementation of view controller now in both our H file and our M file that does relatively little. In the H file, we have a property to that text field. Notice we don't have a property to the go button. Why don't we need a property to the go button? It's not an IB outlet, and we don't really need anything. We don't need to pull anything from it. It, in a sense, is going to push information to us when it's clicked. So we don't need a property for that. And if I look now at my M file, notice that all I've implemented is that IB action. And that IB action is called go, and it just does all that UI alert view stuff. But what we don't yet have is the ability to detect when the user dismisses that UI alert view button labeled thanks. As an aside, IB action and IB outlet, what are these things? Turns out it's just a very clever typedef. Typedef is a way of declaring a synonym in C, in Objective-C, whereby you can give a new name to a data type. And so IB action is actually literally a synonym for void. And void means a non-existent return type. It doesn't return an actual value. So all Apple has done is they have declared that IB outlet and IB action are synonyms for void. So the effect of this is to have no functional impact on your code. The compiler doesn't care. But what Xcode does is it uses regular expressions, essentially, skims your code, and anywhere it sees an IB action, it realizes that it can put this cute little circle here, and it can put that name, go, into the little drop-down menu. Same thing in the H file for the IB outlet. This, too, is just, this actually isn't void. This is quote, unquote. So literally, it's a synonym for nothing. So if the compiler gets rid of that, it has no functional effect, but it does know to put the little cute circle and to put the text field in the drop-down that we saw when I was dragging and dropping the blue line. So it's kind of a clever hack, if you will, to make the interface builder work without having to fundamentally change the language. All right, so let's now wire together the thanks button with our code in a way that allows us to round off the last of the technical topics from the very start of lecture. So we looked at categories briefly. Let's lastly look at protocols. I'm going to go into some of the prefabbed code from tonight into a file called nib2 so that we don't have to rewrite all of that code again. nib2, I'll tell you up front, is almost identical to the previous example, except that in advance I have solved this problem of wiring the thanks button up with my actual code. So let's look at viewcontroller.h. Do you see anything different in this file? What's different? Yeah. Exactly. So we have UI alert view delegate, which wasn't there before. In the previous example, nib1, this file was almost the same, but that was absent. So the fact that I have UI alert view delegate in angled brackets just means that my class, viewController, that descends from UI viewController is also going to implement some methods declared in that protocol. Now, I forget what they're called, but this is easily solved. Let me hold down Option, click on UI Alert View Delegate, click on the reference, bring up the documentation, and if I read this closely, you'll notice that if you add your own button, not that one, what do I want here? Scroll down, this one. Alert view did dismiss with button index. That is apparently, if I read the documentation closely, that is the method that will be called when the user did dismiss with a button index of 0, in the default case, that thanks button. So I just have to implement that now to be able to detect with an event listener that the button's been pressed. So let me go into my M file and see how I've done this. So what did I do here? Interesting. So alert view did dismiss with button index. What did I decide to do? So my comment is kind of spoiling the fun here, but when that UI alert view sends this message to my viewController object, I'm executing one line of code, which apparently does what? Clears the text field. How do I do that? I can simply set the property called text that's associated with my text field to nil, quote unquote, effectively. Setting it to nil is because of the setter, it knows to set it effectively to quote unquote. So that's how I clear it so that I see the placeholder text again, not DAVID. And then lastly, this actually, I did not mean to leave this in the distribution code. This was me tinkering around before. I will remove this. If I leave that in there, as soon as the alert view comes up, it goes away because I was experimenting with a different example. All right, I'll fix that on the online source code eventually. So there's one other difference between this file and the last one, but it's a little subtle. What else have I done that's different? Yeah. Yeah, excellent. So whereas last time the value of delegate was nil, this time it's self. So this is a very common paradigm in iOS, whereby when you call a method on some other object, in this case the object in question is this UI alert view object, and you want to inform that guy to whom he should send a message when he's done doing something, you can pass in a delegate reference, a pointer to some other object. In this case, who do I want to be informed when that button is clicked? Myself. And literally, I pass in, therefore, self. Now, this works because the UI alert view object knows to send the message called alert view did dismiss with index to its delegate. If it's nil, no big deal. It's going to send the message into a black hole, so no one hears that message. But if I'm telling it that I am your delegate, let me know when you're done being clicked on, send me a message, I just have to pass in self. And because I have implemented this method now, I can hear it. If I get rid of that, the message might still be sent to me, but it's just going to go into a black hole as well. But here I've intercepted it, much like registering an event listener with JavaScript or jQuery in the most recent project. Yeah?
I wonder who's holding the pointer to the alert when the method's done.
Who's holding a pointer to the alert when the... so we have in this line here, so this is where automatic reference counting comes into play. So we have here an allocation of the UI alert view object. We have a pointer here. We're then sending the message. Essentially, what is happening here is the operating system is going to keep track of who still has a pointer to that object. And because this is the only guy in existence that has a pointer to that object, effectively when it goes out of scope, it will be reclaimed when it's no longer in reuse. And let me wave my hand at the memory management details for now, because we'll come back to this in particular next week, especially the notion of weak and strong as it might relate to something like this, where you're passing a pointer from yourself to some other object. But this is some of the magic that now happens underneath the hood because of that feature arc. Previously, we would have had to free it eventually ourselves. Technically, there's an auto-release pool that does this for us and automatically frees the memory eventually. All right, so let's take this up one more notch. I'm going to kind of whiz through this code just so that you don't feel that you're entirely dependent on this interface builder. Let me open up nonib.xcode project. And in this example, if I expand the files over here, notice that we again have main.m. And let me emphasize here, when in doubt, when reading someone's code for the first time, certainly lecture examples and even Apple's or others, I think it's helpful to start with main.m just to reassure yourself, okay, familiar, nothing there. Let me now follow the breadcrumbs and go to app-delegate. Okay, now I'm going to go to app-delegate.h. Nothing new here. This looks like the example from a while ago. View controller pointer and a window pointer. App-delegate.m. No, nothing interesting in here. Looks like the brains of the operation are indeed in the view controller. Let's look at the .h. Okay, little interesting here. Alert view did dismiss with button index, go. Okay, that's actually the same as before. Notice I'm being explicit, as someone asked earlier, with read-write, even though that's the default. I could say read-only. View controller.m. So here's the difference. And you can immediately see why I used interface builder at first. This is the code with which I've implemented things without a nib. Notice missing at top left is viewcontroller.nib. So I'm doing it sort of the real way, like without using a little drag and drop WYSIWYG tool. So the price you pay is that it's a pain in the ass. And so here's the number of lines of code I've written. And this is a bit of an exaggeration because I could have relied on some defaults for some of the properties you're about to see. But I included them just to make explicit what the code looks like for a lot of those Photoshop-like attribute settings that I was so pleasantly clicking and dragging on earlier. So load view, if we read the documentation, is a method that comes with the UI view controller class, from which I descend. And he is responsible for loading the graphics onto the screen if you're not using a nib file. So because we have no nib, I have to do everything manually. But it's pretty readable, and I've certainly commented it succinctly, but hopefully clearly. Create view. How do you create the view? How do you create that default rectangle on top of which we start putting all of the other objects? I do self.view. I allocate a UI view, and I initialize it with the frame, much like we did before. Slightly different application frame, but it's essentially boilerplate code from documentation that I learned from initially. And that just gives me that rectangle. Self.view.background color gets white color. That's how I make the background white. So we've seen something like that before. Now it gets a little annoying. I have to use the core graphics library,
Recall that under frameworks, we had core graphics.framework. Well, it turns out all of these little buttons, even though they're kind of ovular, a little curvy, I mean, they're two-dimensional graphics. And they're from lines of code like this. I create a CG rect frame by calling CG rect make. So the core graphics library, turns out, is all in C. So now we're using C code. This is not object-oriented code per se, though it's kind of commingled, as you can see in line 2 here with UI text field alloc. But let me wave my hand at some of these details. But to emphasize this, I looked at Xcode. I looked at Interface Builder from the previous example, and just determined by looking at the little GUI settings that that text field was 20 pixels down, 20 pixels over, hence the 20,20. I also looked at the settings, and it said that the size that I created by dragging and dropping the left and right happened to end up being 280 pixels. So I copied that, and it happened to be 31 pixels high by default. So I really just manually and arbitrarily came up with those values. Now I'm initializing the text field with a frame. So I have to somehow tell the UI text field where it belongs in the canvas that I'm painting with my lines of code. The rest of these lines here, auto capitalization type, auto correction type, these are just essentially properties that I'm setting to constants to turn on or off capitalization and other UI features like that. Things that I would have gotten by checking boxes earlier. And then placeholder, notice I get quote unquote name. And here now, here's where I implement those blue lines. It's a little cryptic, and it's okay if you're not wholly comfortable with this just yet, because using Interface Builder is totally fine, and frankly, I think it's the better way to learn initially. Self.textfield, add target self, action selector go, for control events. Okay, this is a mouthful, and this is not uncommon. In Apple, their constants are very, very, very long, and they're namespaced effectively by having common prefixes. So what's going on here? I am sending a message to the text field to add to it a pointer, a reference to myself, specifically telling it to call the go method, otherwise known as a selector, whenever what event happens. There's that did end on exit event. Recall that Interface Builder kind of dumbed it down and simplified it, made it look grammatically nice with spaces and whatnot, but the constant in code that represents the did end on exit event is expressed this way. And it's just a number underneath the hood, and it's a constant that I would only know by reading the documentation. So these lines of code here that wrap onto 2 lines, this is the equivalent of the blue line that I drew from my text field to my file's owner. All right? Add text field to view. So this line of code, add subview, is taking the text field, taking that default view that's white on the bottom, and putting one on top of the other. That's what adding subview does. It just adds an object on top like you're plopping things down on a transparency. And now this is actually very similar to before. The button I create by creating another rectangle. These numbers I figured out just by looking at what the size of my Go button was in the previous example. Could have come up with any other numbers. Notice that I instantiate a UI button of typed UI button type rounded rect. That's the rounded rectangle that I so easily dragged and dropped earlier. I set what's called the button's frame. So what's the rectangle in which this button is going to live? I then set the title here for UI state, UI control state normal. So buttons have different states. If you touch and hold, it becomes blue usually. That's a different state. Just the normal state is going to be that constant. And then here's how I drew the other blue line. When I dragged from files owner, when I dragged from the button to files owner, this is how I implemented that other blue line. As for the rest of the code, thankfully, this is the same as before. This is the same as before. Everything else is the same. Now, there is one new feature here. These pragmas, these preprocessor directives, these are just kind of a fluffy feature, kind of nice. I haven't used this before, but notice there's a little set of breadcrumbs up here that tell me where I am. If I click on, let's see, the rightmost one here, notice that it's kind of organized. Actions, UI alert view delegate with the bold facing and whatnot. That's coming from this. That's coming from this. It is purely aesthetic, just to kind of keep your methods organized if you care to do that. It has no functional effect on your code. Questions? So in the upcoming project, Draft of Who Spec is online, you'll be implementing a program, recall, named Evil Hangman.
Evil hangman is much like the normal hangman, except that it's evil in the sense that it cheats. So whereas in normal hangman, you might choose like a 6-letter word and give blank spaces for each of those letters, and the human has to guess E, or A, or C, or D, or whatever letters, and you gradually reveal those letters as the user guesses your word piece by piece. Evil hangman's a little different in that, recall, if I guess E, even if the computer was thinking of a 6-letter word that had an E, well, now he's going to change his mind and choose any other word from the dictionary that doesn't have any E's. So he can say, sorry, no E's. If you then are kind of smart in a sort of Wheel of Fortune sense, you go with A, another common letter. The computer is going to figure out, let me find a word in the dictionary that doesn't have E's or A's, so I can say, nope, no E's or A's. So it's constantly dodging your guesses in this way. And it turns out that if you give the user a finite number of guesses, like 4 chances or 5 or some relatively small number, odds are they're not going to win the game, and they're going to feel like an idiot when they realize that the 6-letter word was something so obvious, but it just didn't happen to have the letters they chose. And that's because the computer isn't really changing its mind try after try. It just has a large dictionary of words, and it's constantly throwing words away based on your guesses until you effectively paint it into a corner. So you'll be implementing this in the form of a utility application, which is one of the templates that was provided by Xcode. It's nice in that it's more complex than any of these examples we've done thus far. And we'll see others next week as well as others in lab this week. But the template alone that comes with Xcode gives you this nice little effect. If I click this UI button that looks like a little information sign, notice I get a 2-sided UI. And this is nice because, as you'll see in the spec, you'll be challenged to implement your user interface, your UI views, in the front of this interface. But then there's going to be some settings on the back, some sliders, for instance, that allow you to change the word size to make the game easier or harder, and the number of guesses that the user has allowed. And then when you flip it back by calling done, you'll actually have a chance then to play that game again. This will be a chance to play with NS arrays, NS dictionaries potentially, some of the building blocks we talked about both this week and last, and we'll continue talking about next week, so that ultimately you will begin this process by filling in some of these blanks. And so what I would encourage you to do between now and Wednesday is to actually try to, 1, go home, download the source code from tonight, and actually tinker with some of the examples, delete lines of code, see what breaks, and try to understand why. And I would also strongly encourage everyone to take at least 1 or 2 of tonight's examples, maybe nib 1, nib 2, and try to recreate it, even if you're kind of cheating by comparing your code against mine side by side, but go through the motions of like writing up the code, figuring out how we wired things together, because odds are it'll take you half an hour potentially because you'll miss some stupid little detail, but it's that just kind of muscle memory that you want to build up so that when you really want to do things that are of interest and sort of fun in terms of this kind of game, you won't get tripped up on some of those little nuances. And we'll spend more time on that in lab. We'll also do a walkthrough of sorts to get you comfortable with the spec, and we'll dive in much deeper next Monday as well. So I'll stick around for questions, but otherwise, why don't we call it a night? See you next week.